And let's check out what we are going to do.
What's up, guys? So this is the app we're going to be building. I'll just let this demo running. So what we got here is some urban city driving, some guy on a motorcycle. There's some cars and pedestrians. These guys are about to get hit. And yeah, as you can see, the pedestrians are outlined in yellow and the cars in red and blue. So yep, this is what we're going to be building, you guys, with Python. Super excited. Yeah, as you can see here, there's cars in the background. Some girls crossing the street here. It's doing a decent job. It's not perfect, but it's good enough. So
This is some guys. This is some Tesla shit right here. I'm not kidding. I mean, take a look at this, right? It's able to detect pedestrians. It is able to detect cars, which is just crazy, right? I mean, it's like, imagine basically, you're in a Tesla, right? And you have to figure out, what cars in front of you, right? You need to figure out when to stop. You need to figure out when to go. This is a system something that Tesla would build for their cars. Like, who is up to build a system like that, guys? Huh?
Tesla Autopilot, man. Elon, we're coming for you.
Guys, Elon, exactly. We're building our own startup company to compete with you, Elon. There we go. That's how we're doing it.
I mean, that's ambitious, but yeah, that's the hope. That's the hope.
Exactly. So, guys, yeah, like I said, who's excited to build this? Drop that in the comments below. This is an epic system. Again, we are building an AI for detecting what? Detecting pedestrians and cars with Python.
Pedestrian and car tracking.
Exactly. Pedestrian car tracking. And this is what? This is beginner friendly, right? This is beginner friendly.
Yeah, beginner friendly. The app is not hard at all. If you're a beginner, you should be able to follow along pretty easily. We're going to be using Python and OpenCV. So OpenCV is an open source computer vision library. So that's it. Just Python, OpenCV, and that should get this entire app finished.
Yep. Guys, now before we get going, guys, so here's what I want you to do. I want you to make sure that we defeat the YouTube algorithm system. Help us defeat the AI of YouTube by smashing the like button, subscribing to this YouTube channel, and of course, sharing the video. Is that right?
Yep, that's it. So if you want to see more stuff like this in your feed, then help the YouTube algorithm like this video, and then YouTube will show you more coding stuff, and that's what you want, right? So definitely do that.
Yeah, guys. I mean, look how cool this is. Such an awesome tutorial. Look at this, guys. It's just like it's making boxes around the actual cars, and and it's able to detect them like in real time. We're talking like split seconds.
Pedestrians.
We're talking milliseconds. This is.
I mean,
epic.
maybe not milliseconds. Like, it's pretty good. It's not
that's
quite
milliseconds. I mean, life is happening really fast, right? So it needs to detect really fast, right?
Yeah, it's good. Like, even like you can like see that pedestrian in the distance for a split second at least.
Yeah.
But yeah, I'll just let this demo keep running. It's pretty dope. But yeah, let's probably move forward. Oh, by the way, guys, if you're interested, if you guys like coding, and I mean, assume you guys are because you're watching this video, then here at Clever Programmer, what we do is we teach people how to become developers. Like, we teach them how to make a living from coding, pretty much. So we offer courses. We have a Python course called Profit with Python that gives you a whole 15-week roadmap of becoming a beginner to expert and landing your first job or client with Python. So check that out. If not, feel free to watch the free content on YouTube. This video is free, and we also have a free training if you want to check that out too in the description. They're both down there. Other than that, that's really it.
We have a masterclass training in the description below if you want to check that out. And one thing I really want to mention, we recently had an amazing story from our students. How about you tell this, Aaron, huh?
Oh yeah, this morning. Or yesterday morning, I think yesterday, we had a student land a $90,000 a year $90,000 a year job. So the story is she lost her job due to COVID. She enrolled in our course. She got a $45,000 a year job by being in the course. Lost that job, and then a couple days later, just yesterday, she got a call randomly for a job offer for $90K. So
twice as much.
Really awesome there, but just shows that we do get our students results. But check it out. Awesome. But other than that, let's just get into the code, Nas, because that's what people are here.
Let's do it, guys. Who's excited? To build an AI system like this? Drop that in the comment below, and we're going to be doing this together, guys. We're going to be learning this together. So make sure to smash the like button, subscribe, and let's get into it, Aaron.
Heck yeah, man. Okay, so, I think this has been going on long enough. Let me just cut this and clear my terminal. And let's go to a presentation. So I just want to give you guys a quick presentation, a little bit of context before we actually start coding. If you want to skip this and just skip right to the code, feel free to jump to the timestamp. The link will be in the description. This will take like 5 or 10 minutes. It's fine. I'm just explaining how the algorithm works and stuff. So let's get started. So car tracking with Python. Okay. with a couple cute little emojis there. So first of all, we're only using computer vision. So you guys might have seen some self-driving cars. They have like this weird radar thing on the roof of the car, and it like spins and stuff. It's like
like the Google one, like the Google one.
Yeah, like the Google one, and I mean that's like using lasers and radar and stuff, and it kind of sucks. But we're not doing that. We're only using computer vision because that's how a human works. You just use your eyeballs. You don't have like a laser sensor. Okay, so only computer vision.
Yep.
And the reason we're doing that is because Elon Musk says so. Okay, Elon Musk here, he's my dad. I coined him as my daddy Elon. But I'll show you.
Sure. Okay, sure.
Computer science only, and a little bit Elon there.
Damn, that is some cool Elon.
Tesla stock is up. So this worked.
Guys, don't smoke though. We don't encourage smoking, okay?
yeah, none of us smoke anymore.
Exactly.
Anyway, so yeah, this is the little article that I found. There's actually a video of Elon saying it. He's kind of curt about it. He's like, anyone using LiDAR is doomed. And pretty much the reason for that is it's bulky, it's expensive, it's not effective, and humans can do it with just their eyes, so a car can too. Okay, so we're going to be using computer vision just like this and not like this, all right?
Beautiful.
That's really it. So let's explain how this works, okay?
Yeah, let's do it, man. I'm very curious. Ooh, what? The slide didn't load? Oh, there you go. Interesting. Now they do. Okay, let's keep going.
All right, so let me get rid of this zoom thing. It's in the way. All right, so step one. So how does this actually work?
Good question.
This is gone. 1 second, guys.
There we go. What happened there? That's all right, guys. That's okay. We got, you know. No. There we go. Step one.
Anyways, I mean, that's kind of screwed up. But anyways, so step one is to get a bunch of car images. So what's supposed to be here is actually this image, but in color. Okay, so just pretend that that's there. So step one, get a bunch of car images that look like this. Step two, you want to make them all black and white. So that's what it'll look like. And the reason we do that, I believe, Naz, you asked earlier, is because when it's black and white, it just makes the algorithm faster because there's less data. You don't have to worry about color data. It's just relationships, and you can still tell that it's a car even though it's black and white. Am I right? Or am I?
That is true. They can still take a lot of things, but yeah, I mean, yeah, and if you have RGB color, right? So you have to have colors. I'm guessing it's gonna take a lot longer to process because there's just so much more data in there, and so we kind of scrap that and be like, nope, no, we don't do that. And interestingly enough, actually, if you look deeper, I think Tesla does the same thing. So Tesla, when they actually go ahead and process their videos, they process their video that comes through cameras, they turn that into black and white, guys, and we are doing the exact same thing. Like, how epic is that? You know?
Yeah.
I think it's
so.
Epic.
I mean, yeah, it's the first step. You just got to turn black and white because it makes things faster, and Tesla's all about being fast. And then step three, once we have the all the images in black and white, like you get a bunch of car images, make them black and white, just like Tesla. Then you're able to detect and track cars. All right. And basically the same thing with pedestrians, but I'm just using cars as the example here. Yeah. So that's kind of the brief explanation of how it works, like overall. I'm going to go into a little bit more detail here for some context, and then we'll get into the code shortly. So how does the computer train the algorithm? Like, how does it go from this to knowing what a car is in each of these images? How come it didn't put the red like square like over here where it was incorrect? It's actually correct in all of these. How does it do that? So very simple. Question. Yeah, I mean, computer algorithm behind it. We're just going to explain it in simple terms for people to understand. So very simple. We use these. So these little box-shaped things are called Haar features, and pretty much what they are like little building blocks, like little Lego blocks that you can use to define something. And that doesn't make any sense, but on the next slide I'll show you how it works. So pretty much we just do this. Let me zoom here so I can show you guys. So as you can see, this is a picture of a car here. Okay, a rear end view, and as you can see, this little window is like a dark patch, right? And this little thing down here is a little bit lighter, like this area is lighter. And then again, the shadow is a little bit darker. So what we can actually do is we can take one of these Haar features like we have right here, this one, like this one, but inverted. And we can actually say that this kind of matches right over here because it's kind of darker up here and lighter down here. So we can say that this Haar feature matches this location on a car better than it would match here where it's just flat or flat green up here. Okay. Right. So, and the way it does that is it just takes all of the pixels. It just takes all the pixels in that black square and adds them up, and then all the pixels in this white square and adds them up to one number, which is just like the way to really boil down like to a single number how dark or how light that entire box as a whole is. And then you can compare those two numbers to be like, if those two numbers are far enough away from each other, you can be like, okay, this rectangle is a lot darker than this rectangle, or this rectangle is a lot lighter than this rectangle. And that's what essentially what's happening here, because this rectangle is darker.
And so it almost creates like a shape. It almost like creates like a shape basically, because if it knows, right, darker up top, white at the bottom, and then it can continue on doing with that, it creates like a shape, and it remembers that shape basically, right?
It'll just find that this match is pretty good when you're training the data, and you're like, okay, this Haar feature of this size kind of matches a car pretty good.
Right.
Okay. And then we can also say, likewise, like I said, there's a shadow down here, and this one's a little bit bigger, and there's a white strip. You can kind of say that this Haar feature would match down here, because if you cover the shadow, it's kind of darker on the shadow and lighter on the bumper. So you can actually say that this is also a good match for a car. And then these two added together, you can actually see that this dark window in the bumper and then this dark shadow in the bumper are kind of like, these two Haar features together kind of define a car even better than any of them by themselves.
Yeah, so you guys want to take a look at the shadow, the shadow below, and if you look at all the other cars, guys, they have a shadow below as well, right? So that's kind of how it kind of starts to recognize that. So that honestly is so interesting. Like, guys, who's excited to learn something like this? Because honestly, applying this into your real world, into your life, is so extremely important. Mainly because like you know, with Tesla, with GM, with all these companies, they are going towards this. They are going towards autopilot. So just imagine, right?
Self-driving
Let's just imagine the amount of jobs that this will create, right? Like, it's just the amount of jobs with Python, with machine learning that's going to create in the future, in the coming future, and already is insane, bro.
Yeah, the Uber's going out of business, man. Like, Elon Musk said that there's going to be robo-taxi soon. I might have already said this, but if you're an Uber driver, you're gonna lose your job soon. You should probably become a programmer instead, because then you can program the cars instead of drive them.
Exactly. But, Profit with Python, link in the description.
Years, maybe 10 years max, and then your job is done. So hop on that quick.
Okay, we don't know about that, but let's not be so harsh. But let's continue on, bro.
I got faith in Elon, man. Like, what are you doing, doubting my daddy? Don't do that, bro. End the stream right now.
Let's continue on.
Anyways, so that's how it works. The idea is these two Haar features match nicely for a car, and you can chain like thousands of these together, and all added up, all of those Haar features added up will kind of match to what a car is. So these are just two examples, and same thing works for detecting pedestrians. So I'll show that next. Okay. Let's go to the next slide real quick. So yeah, the same exact idea with pedestrians. You get a bunch of images, okay, of pedestrians. You make them all black and white. You want to run all of these Haar features over all these images to find which ones match in which locations. And then eventually you'll train it enough for it to be able to detect actual pedestrians. So for example, like if you look at this pedestrian here, then maybe this Haar feature will be really good. Like if you took this Haar feature and stretched it taller and put it over, you can kind of say that like maybe here is like a darker person, or here is a darker person. And then you have the lighter areas on the sides. Okay, so you can kind of use that. That's kind of a good match. Also, you can see her pants are very dark here. They're basically like dark blue or black or something. You could say that this Haar feature, if it was a little bit stretched taller too and skinnier, then you can say, okay, this Haar feature matches good. And same here, because usually people are wearing pants and shirts of different colors. So you could say that also matches a human. A pedestrian.
And so again, it almost like creates a shape again. You know, it uses all those black and white boxes, it counts them in, and it creates a shape. And knows, okay, so if this kind of a shape matches, right? This kind of shape is created, it matches a human. If this kind of a shape is created, it matches a car, or it matches a pedestrian, right? So that is the interesting part about that.
Or a Pepsi can, or a Coke can.
Yeah, you know, or an apple. I don't know, whatever you want.
Anything.
You know. Yeah, but this is it.
Distinguishing apples from pears, like that's a little bit trickier, and then you probably need to keep the color in there at that point. But I mean, this is just a generalized explanation. Of course, there's always a trade-off of accuracy and speed. So it takes a lot more work to distinguish an apple from a pear than it does from a human to a car, because they're just very different things.
True that. Sweet, man. All right, let's continue on.
Yep, that's it. So let's just jump into the code. Let's code it up.
Hey, let's go, guys.
We're probably like 12, 15 minutes in. But again, timestamps in the description if you rewatch stuff or skip anything.
Yeah.
But let's get into the code, okay, guys? Are we still live, Nas?
Yeah, we are alive. We're all good. We're all good. We're all good. We're all good. Let's continue on, guys. Who's pumped to build? Who's pumped to build an AI system like this? Who's pumped to build an AI system for car and pedestrian tracking? I'll put in the comments below, and we're going to get started right now.
Got it. All right, guys. So I got the code up here and running. This is what was running the demo code. It's actually not that long, as you can see. It's just a few lines. All this here was doing all of that. It was taking in the image. Not the image. It was taking in the video of the guy, the dash cam, and the pedestrians, and then it was finding everything, detecting everything, and displaying it to the screen. That's all happening right here. Okay?
Right. Okay.
So let's just jump into it. We're gonna start with just an image, and then we'll go to videos second. But yeah, feel free to follow along. So if you guys don't have VS Code, you're gonna want to download VS Code. You're probably gonna want to pause this video and download it because I'm gonna be going a little bit faster. Yeah. But download VS Code, get it all set up, and that's it. Next, what you're going to want to do is you're going to want to create a Python file. And you can call it whatever you want, but I called it car and pedestrian tracking.py. Okay, this is the one I had before. I'm just going to be copying and pasting code over to show you guys how it works. I don't want to have to type it out. It's the same thing pretty much. But you want to start here. Okay. Next thing you want to do is install OpenCV. So you can do that through the command pip install OpenCV-Python. Okay. And if that doesn't work, then try running pip install the same thing, but just add headless at the end. Okay, there might be an issue there. Yeah. One of those should work if you're running on a Mac or a Linux computer. If you're using Linux, you're probably already a badass programmer, so you don't even need to know this stuff. But again, you can just do a Google search like how to install OpenCV on your computer. If these don't work, you're gonna kind of have to figure it out yourself because I can't help with every error through this live stream. But wait, guys,
we're about to cross 100 likes, so let's keep liking the video, guys. About to cross 100 likes. Like the video. Let's continue on.
Yeah. Where was I? Install OpenCV. So once you have that installed, you should be good. Okay. The way you can test that is you can just put Python. Okay. And you have your little Python environment here in your terminal. And if you know what this is terminal. So you want to go, you can do command space on Mac, and then this little spotlight thing pops up and type in terminal, and just hit enter, and then it'll pop this up, and this kind of tells you, gives you access to your computer. So if you type in Python, then you can do stuff like hello, okay?
Yeah.
And then it'll print hello, whatever it says there, or
Nice.
Daddy.
Oh my god. Elon is not your dad, bro. Come on.
Man, you just let a boy dream.
You look very different.
My dad.
No. Don't even think about it. No, Aaron.
Anyways,
don't even think about it.
Back on track. So to make sure you have OpenCV installed, you can just import CV2, which is short for Computer Vision 2. And if you hit enter, then this will happen. Nothing will happen. It'll be fine. If you get an error, it means it installed incorrectly. So just make sure that when you run this, it just goes to the next line. There's nothing happens. That means it's installed correctly. Then you're good. To get out of Python, you can just do Control-D, and it'll go back here. And I'm just going to type clear so that we're back to the terminal. But once you have OpenCV installed and you have your Python file created and you have it open in VS Code, we are ready to start coding. Okay?
Okay.
So
now, guys, looks like Edwin just gave us a €1 super chat. Edwin, thanks so much. Appreciated. And let's continue on. Yeah.
Dang, I think I got my lunch now, right? With that money.
I know, right? I know.
Anyways, so let's just start with a simple code completed. So this is a little thing I like to do. I put this print statement at the end of my program so that I know if it prints that the whole program completed without any errors. So let's just run this first. So this is the first thing that I'm going to run. Go to the terminal. Make sure you are in your desktop. So PWD stands for present working directory. And as you can see, I'm on my desktop. If you're not, then if I'm not on my desktop, let's say I'm at my user file, then you want to put in CD, which is change directory, and then just type desktop, just like that, with a capital D, okay? And then once I do that, then I am in desktop, okay? Then once you're in desktop, that's where I have my files housed. Or if you have all your files housed in a folder, then you got to go there instead of desktop. But for me, I just have it on desktop right here.
That's a massive file structure, bro. But anyways,
bro. I'm just teaching them how to code. Like I don't know how to keep my computer organized. Like, this is free content, you know.
All right. Okay, fine.
This is Aaron's stream, bro. Get off the stream now. So I don't need you. Just kidding. I need you to help me. Anyway, so let's run this code. So the way we do that is we just write Python, because this is a Python program. And then we want to run car, I think I gotta put dashes. Car, there we go. So car and pedestrian tracking.py.
Okay.
These little slashes mean it's a space, because it's kind of silly when there's actual spaces. Like I had underscores in the other file, but ignore that.
Yeah. And the way, by the way, and the way Aaron was able to get that is he simply started with he typed in car and then he pressed tab right away, right? So he pressed tab, and that's what basically right away it autofilled, because we got autofill and
it auto finds any files that has car at the beginning, and then it gives you all the options.
Exactly.
You can just type it all the way out. Maybe just use underscores, because then it gets rid of this nasty, complicated thing with this stuff. If you just use underscores in all your file names, and you can just type out this exact thing, and then you won't have all this weird stuff. It'll just look like, that.
Yeah.
Okay.
Yeah, exactly.
Use underscores, it looks nicer.
Nice.
But for this video, we'll just use this. Okay.
That's fine.
So when I run this, because it says code completed, then we should see code completed pop up here, and voila, it does. So that there,
okay,
unsurprisingly, because there's just a print statement. But like I said, when you're running OpenCV, you want to run import CV2. Make sure you save. And if we run this now, and this prints out, we know that this is working correctly. If this doesn't print out, then that means there's an error here importing, and then we'll see it. But I think it's going to work. So you can press the up arrow key to repeat your last command, and just hit enter again. And as you can see, no errors. So
guys,
looks
and that's it. Our program has been completed. Thank you very much. No, I'm kidding.
Your whiteboard joke, man. Get out of here.
Let's continue.
All right. So let's start with just detecting cars and images. All right. So I have a little mini program up here. Let me just comment this out. It's a comment out in Python. You can just use triple quotations like that, and everything between will be commented out. And let me just get these. There we go. Save this. And here we go. So it's even shorter for just an image, but we're going to go through all of them one by one and explain how it works. Okay.
Interesting.
So let's start with this. All right. So first thing we're going to do is we're going to want to decide on an image. Of course, if we're going to be detecting cars, we need an image that has a car in it to detect. Okay. So I just have an image on my desktop called carimage.jpg right here. Carimage.jpg. This is the same one that was in the slides I was using. I just cropped it out. Yeah. The same exact image.
And we literally just got these images from the internet, so don't think it's anything special. It's just an image from the internet, and we're using that kind of.
The videos I'm actually using in this tutorial, the links to the YouTube videos I stole them from are in the description. So credit to those people. The guy on the motorcycle, he has like 2 million subscribers for riding his motorcycle around cities and like revving his engine at hot chicks. Like, it's pretty cool. But
all right, okay.
I use a video from him, and that's where I get it from. So this isn't spoofed. Go check it out there. You can also use a YouTube downloader to get the videos yourself. If you want to use the same videos, then by all means do it. Dope. So this is the carimage.jpg, okay, right here. And that's it. So the image file we have is just carimage.jpg. Very simple, okay? And let's just run this. This is called unit testing. Every time you write a new line of code or like a different group of code, I'm a little bit OCD and psychotic and do it every single line. I run it to make sure code completed prints, because if it doesn't, that means the line I just added screwed something up.
Right. Okay.
Okay. Called unit testing, because you want to test every single unit of change in your code.
Right.
Even you can be redundant, even if it's like as simple as, oh, I deleted something. Like you thought you deleted the D, but you actually deleted this. That's gonna screw you. It's gonna break the code.
True.
But yeah, pretty self-explanatory. That's the importing the image there. Second thing is we are going to want some way to be able to detect and track cars, okay? And pedestrians, but let's just start with just cars.
Okay.
So let's start here. So these are our image. Let me put in some comments, because comments are good. It's good coding practice. And our pre-trained car classifier. Okay, so this is a little bit wordy, but all it is, like I said, when you train the algorithm with the Haar features, and you have a big list of Haar features that defines a car, when they're all added up, like the dark boxes and the light boxes, all of those added up define what a car is. Like, it kind of captures the pattern of what a car looks like in an image or in a frame of a video. Then you encapsulate all of those numbers and Haar features in a file, an XML file. So I think, so what this looks like, I can actually open it right here.
Okay, let's take a look at it.
If I just open this up, then this is what it looks like. So car detector.xml. So all this is the result of training the algorithm. This is what the algorithm at the end spit out after you put in thousands of images. Oh, by the way, I totally forgot. The car images, the data set that I stole. Sorry, guys.
Stole. We borrowed.
We borrowed. Man, I'm gonna die on the stream.
You got some water? You gotta get okay.
What's up?
Get some water, you know?
Yeah, I got some right here actually, so okay. I'm gonna drink while I'm talking.
Alright, cool.
Should be good.
Right, awesome,
I'm a master of conquering hiccups.
Okay.
Anyways.
Alright.
So we're not actually gonna train the algorithm ourselves on this video. That takes way too long because like it takes like a long time for a human to learn and build a habit. It takes a long time for a baby to understand what a car and a pedestrian is. The same way it takes a long time for a computer to learn what a car is because you have to give it thousands of images and run all the thousands of Haar features at every location of every size of every orientation until you eventually decide on the Haar features that match nicely for a car. And then once you have all of those, then you're good to go. But the end result is pretty much this. Okay, so this is just like some encoding. I actually don't know how this works exactly. It's just the XML encoding is what they use. But the idea is you can generate one of these files and it has all the numbers. Like these numbers are like different coordinates and different colors and different thresholds of like, okay, is this a Haar feature? Is this good enough? It needs to be above this number, below this number. And it just goes through the entire list of thousands and thousands and thousands. Oh. Yeah, guys, Kazi called me. I don't know if you guys can hear. 1 second, guys. Oh, we got another donation. Dope. Got it. Yeah, I'm not in the chat, guys. I think we overlooked that, but somebody donated. Are we still live, Nas?
Yeah, we're live, of course. All right. Yeah, okay, let's keep going. There's no. I was just talking with Kazi. Kazi called me. We were like, Yeah.
All right, guys, so we're back on track. Somebody else donated. I think we missed on the chat because we're focused on the code, so we overlooked that. But Nas, keep an eye. So whoever that was, I don't know their name, but appreciate that. Very appreciate that. Appreciate the gesture. And where was I? Yeah. So this is the long list of Haar features. It's gonna go through all of these, and if the image passes all of these, you can say, okay, yeah, this is a car. Awesome. Or like a little patch of an image. If the little patch passes through all these and it's a yes all the way through, then it counts as a car. If not, it's not a car. And then that's how we know where they are. So you're going to need to specify this file because this is what's going to tell us what a car is and what a car isn't. And the link to this file is actually in the description. So you can just go download this. It's just a URL. Just go file, save as, and you can download this. It's actually just called car.xml, but I added detector for the video. So download that. Okay, that's the explanation of that. A lot of explanation for one line of code, but I don't just want to be like, hey, just download this file to work. Like, nah, I'm gonna explain how it works so that you have an overall holistic understanding. That's the proper way to do stuff. Okay, we're actually programmers. I mean, we're lazy half the time, but it's fine. All right, so moving on. Now, the next thing we're going to want to do is we're actually going to want to create an image within the OpenCV format. So this here, of course, this is actually just a string. Okay, car image is just a string in Python, but we want to give it to OpenCV, remember CV2, and actually read the image so that OpenCV can actually use it correctly. Okay, so all we're going to do is we're going to call OpenCV.ImageRead and pop in the image file, the name of the image file, which is just carimage.jpg. Again, carimage.jpg right here. So we're reading this into our program. And from there, we have it in here image. So that image is actually now in this variable here in our program, okay? So why don't we just show, I believe.
So the image read file basically like takes in the image and all the, and it processes it as like data? Is that what it does, right?
Yep. So it just reads in all the pixel data from that image file and then reads it into some double multi-dimensional array. So, like a big array, a double array of an array of arrays so that every pixel has its own data. And then it's just all encoded into this one variable here, image.
Right. Gotcha.
And now what we're going to do is we're actually just going to this is not a face detector. This is a car detector.
Okay.
We're going to display this image. So there is a, we're also going to need this. Just one second, guys. So these 2 lines of code that we're currently working on, we got the image in our program. Next, we're going to need to show the image. So OpenCV has a function or method called image show. And the first thing is the name of the window. So the name of the window, like here is car and pedestrian tracking.py. That's what'll pop up there. And then the actual image you want to show. Okay.
Okay.
That shows up. And then in OpenCV, this basically just means display. So OpenCV.waitKey, you need to run this line of code so that it actually displays. Otherwise, it'll display for a split second, basically 1 frame. So like literally a split second, then it'll disappear. But this says wait until you hit a key before it disappears. So it kind of like this displays for a millisecond, but this makes it pause. And so you need both.
Okay.
This is kind of just like display.
By the way, I just want to say thanks to Lars. Lars donated looks like a euro as well, so appreciate that, man. And we got so many guys. We got so many people in the comments between Abdullah, between Kristen, between Chax, between Kant, Usma, Vicky, right, Joshua. So many of you guys amazing and so excited in the comments. I'm excited that we have such a great community, man, literally. So yeah, I just wanted to mention that because so many amazing people. Let's go ahead and continue on.
Awesome, you guys. So let's just run this code now. All right. So again, we imported OpenCV. We got the image file. We have our car classifier. We import the image. Okay.
Okay.
And I just want to show you the image now real quick, okay, to prove that the image is actually showing up and is within our Python program. So this will actually pop up a little window with the image, and that's it. It's not detecting anything yet. It's just going to show the actual image. So boom, right there. As you can see, it says clever programmer car detector, and that's the image.
Right.
Okay.
Okay.
And remember, this title is from here.
Okay.
So that's that.
All right.
Now let's just quit out of this. So it's waiting for a key press. If I hit space bar or any key, it'll just quit out. And now we can continue on. All right.
Okay.
So now we're going to be coding in here because, of course, at the end, we want to make sure we're displaying the image at the end. But now we have our image in our file. Okay. So now that we have the image and we have our classifier, how do we actually find where the car is in that image? Because I mean, there's a car here, there's a car here, there's a car all down here. I mean, granted, these are half cars, so it might not detect these. I don't think it will. But these full cars, it definitely will. Okay. Oh, Kazi's calling again. Hey, what's up, Kazi? Live stream is dead? Oh, stream is dead now.
No, you're not on mute.
No, it's running. Is the stream up, guys? In the comments, can you guys drop in the comments?
It should be running, guys. Right? It's running. You guys hear us? It's working. Yeah, it's all good, guys. All is good.
Got it. All right,
it's all good. It's working now.
All right. We don't want another dead live stream. You guys, it's terrible because it keeps getting cut off. But
yeah.
I think we're good, right? I think we're good.
Yeah, we're good, man. We're good.
Anyway, so this is the image that's going to be read in, and from here, we want to be able to classify that this right here is a car. So it's like if we pass this little rectangle of the image through that whole XML file, and if it gets all the way to the end, it's like, okay, cool. This square counts as a car, and this square does not count as a car. Okay. So that's what we're going to be doing. So the next step to do is to actually create our classifier. So that's pretty simple. That's just this line right here. Let me show you guys. I'll copy and paste this, and we want to create our car classifier. So all it is we run this function, OpenCV.Cascade classifier. Because again, we are running a Haar Cascade algorithm. That's why it's called Cascade, because there's a cascade, a long list, a long chain of Haar features that we're going to run it through. And classifier is just classifying something as a car, or classifying it as a pedestrian, or classifying it as a face, or an apple, or whatever, but in this case, a car. And the classifier file is what we just specified, the XML file. So we just pop that into here. And so OpenCV, we're just going to create a classifier from that file. And then we're just going to call it car tracker, because once you have a car tracker, now we can apply this car tracker to this image, and we can actually find where in this image if there is a car or not. So here there's a bunch, but it might only detect a few, but that's the idea, okay? So in an image, we have a car tracker. Now we just want to apply this car tracker to the image and then spit out the rectangles, okay?
Right.
So let's move on. I mean, again, this doesn't show anything. We just have the car tracker created. If I displayed it, it's just going to be the image again. So I'm going to move on. Like I said in our presentation, we do want to convert it to black and white though first. So let's just do that next. And the reason for this is because it speeds up the algorithm, makes it essentially 3 times as fast, because instead of 3 colors RGB, we can just focus on black and white. That's it. So
you're simply converting basically from color to black and white.
Yep. Same as the face inspection. If you guys want to,
why don't you do that before you classify? Is my question. Like, why don't you do that before the classifier?
I mean, you're just creating it. We can shuffle this up. It doesn't really matter.
Yeah. Doesn't matter. Okay.
Yeah, doesn't matter. I mean, this might make more sense because you have the image, then you change it to black and white, and then create the classifier.
Gotcha.
I mean, we could even do this. We could keep the order different. So like, we've got an image here, and then we read in the image, and then we change it to black and white, and then we get our classifier, and then we create the classifier, and the point is, what we want is we want to have this classifier and this black and white image ready. So once we have both of these, we can do this in any order. Then we can pair these together and actually get the images. Okay.
Nice.
So I mean, I guess I'm gonna put it back here because I like keeping all of the static stuff together because these can change. Like, you can change the file very easily here, or the file very easily here, just by changing this, and all this code remains unchanged.
Right.
So here's
we got somebody asking how can I donate. Oh my gosh, some of you guys are asking how can I donate. Dang, really appreciate that, guys. That is so awesome. My PayPal is my
my Venmo, my OnlyFans, like I got everything.
Just PayPal to that,
Yeah, my Snapchat.
Oh man.
No, I actually don't know how you can do that. Do you know, Nas?
I don't know. I think Kazi's got it. He's got it taken care of. All's good.
Cool. Yeah. Or we can hook you up with something. Maybe there's something like a $5 course, something. I don't know. We can hook something up. Who knows? Anyways, back to the code, you guys. So once you have the image read in, you want to change it to black and white, like we said, because it speeds up the algorithm, and you can still tell what a car is and what a car isn't in black and white images. So it's totally fine. You want all the improvements you can have. There's always a trade-off of speed and accuracy pretty much in everything in life. So algorithms are no different. So you kind of want to change, like an apple and a pear. If you go black and white, it's going to be much harder to distinguish the difference. But a car and a human, very easy to distinguish. Okay.
Right. Yeah. That's true.
So the way we do that is OpenCV. There's a function called convert color. So all you're going to do is this allows you to convert color to black and white. It allows you to convert black and white to color, and there's all different kind of color encodings. I'm not going to get into crazy details, but the point is this allows you to convert the color stuff of an image to whatever you want. I could even make it all red, like have only the red channel and it'll look really red and stuff like that.
All right.
So I'm not going to demonstrate that here, but let me see actually. Now I don't want to go down that rabbit hole. The point is you can convert the color of any image. So we're going to feed in the regular color image here, and then all we're going to do is we're going to say we want to go from color from BGR to gray. So BGR is just RGB backwards in OpenCV. In OpenCV, RGB is like the color of a pixel. Everybody should know that. If you don't, well, now you do. Then they just use it backwards, so it's BGR. A little bit confusing. I don't know why.
That's so weird. That's so weird. Like, it's like the standard was like. By the way, if you didn't know, guys didn't know what RGB stands, it's red, green, and blue. Those are the 3 main colors. The all the other colors are made up of. If you didn't know that, so that's something interesting for you. Yeah.
Each pixel has a red, a green, and a blue light, and then it just makes the brightness of those 3 different levels, and the combination of those 3 levels can make any color pretty much. If they're all maxed, it's white. If they're all off, it's black. Okay, for RGB. But for gray, it's just one number. There's no 3 channels. It's just is it 0 to 100 or something? Okay, from 0 to 100%. Like, what's the brightness? That's all it is. So we're just converting RGB to gray. And once we have that, I just call it black and white because why not? Now we can actually display this black and white image. So let's take this, and in our image show down here, which was showing the color image before, let's just change this to the black and white image. And of course, we need this to display for longer than millisecond. And this should actually give us the black and white image. Okay, so let's just run the same thing again. Again, your up arrow key will allow you to go to the last command you ran in your terminal, hit enter, and voila, we have a black and white grayscale image.
Okay, interesting, guys. Give Aaron some round of applause in the comments below.
I ran 6 lines of code, you know. I've been coding for 8 years.
And we converted an image to a black and white image. That's what we just did.
This is all I learned in 8 years, guys.
Exactly.
Please
all
give me
all
the praise I
eight
deserve.
years in college. 8 years in college, you know.
It's at grad school, pursuing masters and everything. Anyways, so that's the black and white image. So now that we have the black and white image, we can actually apply the car classifier to that image, and then we can get the car in the image out. Okay.
Yeah.
So next thing we're gonna want to do is actually detect where the cars are in the image. So let's run that next. Okay.
Okay.
So I'm gonna.
You got it? Are you trying to figure out what line to write this on?
No. I just kind of want to like segment like these are the 2 files. Shut up.
It's just like wait, write down this line, or this line, or this line.
Duke it out. They would like that on the live stream.
Guys, drop in the comments below what line should Aaron write the piece of code on.
Who would win in a fight, Aaron? That's what I want to know.
Actually, cool. Good question. Who would win in a fight? A good question.
I mean, you're more
drop that in the comment. Drop that in the comment below. I'm very curious.
Physical fight would be you.
We'll see. One day.
Anyways, so the way you detect things in OpenCV is once you have a classifier object, a car tracker, you can apply this to an image. So all we're going to do is we're going to say car tracker, and we want to detect multi-scale. So what that means is detect cars of any size, of any scale. Okay, so we're going to detect cars. It doesn't matter if the car is big or small. It's going to detect it no matter what. Or even if it was even bigger, it'll detect that too. Okay.
Got it. So wait, some of you guys, what editor is this, guys? This is using VS Code, guys. Yes. Okay, VS Code. So like, you just download VS Code. It's the most important one you'll ever use as a developer. So yeah, it looks like what wait, who is this? Hanshika asked that. So yeah, just download that and you should be good.
Yep. Oh, by the way, if you guys want to have the documentation for OpenCV, I'll link that's linked in the description too, so you can check all these files because there's a lot of cool little things you can tweak. I'm not gonna go over all of them extensively. I'm just getting the app done. But detect multi-scale, there's cool things you can add on to the end to kind of like tweak the algorithm to make it perform better or worse. That's linked in the description. I'll just show it right here though. Detect multi-scale. So this is the documentation. Again, link in description. Just click there. It'll zip
link
you
in
right
bio,
here.
Guys.
Yeah.
Cool.
Link in bio. Link in description, man. The same Instagram.
Link in bio. I'm used to that, you know.
I know. You fucking dirty millennial.
Okay, listen. Let's focus on the work here, okay?
It's fine, man. Like, I don't like those boring videos, boring live streams. Like, we just have fun. Anyways, so detect multi-scale. So of course you take the image in first, which is what we were doing here. We're just passing in the image, the black and white image. But then there's other stuff you can add on. There's all this cool stuff, reject level, scale factor, minimum neighbors. You can read all the details here if you're interested. But you don't need it for the app to work. I'm not using it. So that's really it. So detect multi-scale. You just plug in the black and white image with the car tracker that we got, again, from this XML file, which was trained with the images and the Haar features. So that's the whole entire holistic view. And once we apply this tracker to this black and white image, it'll pick out all the places in that image where there's a square that contains a car, and it'll give us the coordinates of all of those cars. Okay?
Okay.
So why don't we just print this out and see what the hell is in cars?
Okay. Guys, this is getting interesting. Guys, this is getting really interesting. All right, let's see. Let's
run it, and boom. So again, the black and white image is popping up because I still have these 2 lines of code down here running.
Okay.
But before that, I printed out cars. So all cars is
just the numbers.
Yeah.
Really? That's it?
Coordinates.
Really?
So, yeah. I mean, I guess it's only detecting 2 cars in this. We'll see exactly where they are in a bit. I already know ahead of time because I ran this before, but it detects this big car in front and this little car on the right. Reason being is because these are all half cars, so it's not quite smart enough to get the half car. But actually,
that's a good question, guys. Guys, which cars do you think it will actually detect? Let us know in the comments below.
Bro,
man. See, you gave it the I know you gave it away, but this is come on, bro. You gotta not give it away so easily, you know. But
easy mode. I mean, like, it's impossible to predict, bro. Like, not even us. You just run the program and see what happens. Like, come on. But
still.
Anyways, so yeah, it's gonna detect this one and this one. Okay, so there's only 2. Spoiler alert. But these are the two cars. So these are just the coordinates of where the car is. It just kind of like defines this square. That's all it's doing. Okay. So there's two cars, one car here, one car here. If there's 10 cars, like in the video stream, there's going to be like 10 of these in here instead of just 2.
Right.
All right. So that's really it. Let's go back. And now all we need to do is once we have these coordinates, we just want to draw a rectangle around that car so we can actually see it. Because we know where it is, we just can't see it because there's no rectangle drawn on the image yet.
Wait, so those numbers were actually rectangles, is what you're saying?
Yeah, they kind of define the coordinates of the rectangle.
The top left point. Yeah, interesting. Okay, I got it. Okay.
This is the top left point of the rectangle, and this is the width, the height. See, it's the same because it's the square. This is the width and the height because it's a square.
Yeah.
That's all.
Interesting. Okay. Gotcha. Yeah, applause for that. This is really cool stuff. Yeah. You guys don't hear Aaron. You don't hear the sound. Aaron, you don't. I'm in the chat. Aaron, you don't hear the sound effects, but we have some amazing sound effects going on in the background, just so you know.
Some amazing sound effects.
Yep. You'll see it later. Don't worry. No, you'll see it later.
Oh, in the stream. Okay, I thought there was something was like dying outside in my background, but there's nothing happening, bro.
Yeah.
Awesome.
All right.
Anyways, so this is just like because they're squares by default. We're detecting things within a square. So this is the width and height of the square because it's the same number, width and height of the square. And then this is the top left point in the image of where it is. So from here we can be like, okay, this is the top left point. Now just draw a square of these dimensions at that point, going down to the right, and that's actually where the car is in the image. So there's 2 in this one. Okay, so we have top left point and width and height. Okay, if you guys watched the face detection video a couple weeks ago, very similar. We're just detecting different things and applying it differently, but same idea. Okay.
Got it.
So
guys, who's ready? Who's ready to see some squares and detection squares? Huh? Who's ready? You guys ready? Drop in the comment below. And Aaron, let's see it. Bro.
Got it. All right, you guys. So, it's gonna be
what's up?
BGR. So this is actually wrong. Let me explain this. So I just copied and pasted. Actually, let's get rid of this for now. I don't want to ignore this loop for now. Actually, let me just delete it straight up. Delete it because I want to explain it line by line.
All right.
Oops.
Let's go, Logan. Okay. Hey.
So here we go. Here is the line to draw a rectangle. So OpenCV allows you to draw a rectangle on any image. Very straightforward and simple. So it's just called dot rectangle. So OpenCV dot rectangle. And then it's like, okay, what rectangle of what size, what color, what thickness, and where do you want to draw that rectangle? So this is all these specifications here. And of course, we have that data within cars. So if we have the data in there, then we can just print it out here. Okay.
But where are you getting the X and the Y, though, is a question. Where's the X and Y coming from?
From here. So we're going to get that data out of here. So remember, remember we have these here. So this is going to be X, this is going to be Y, this is going to be width, and this is going to be height.
I see.
And then from there, we can just X, Y, and then X plus width and Y plus height. And then this is the color. This is the color of the rectangle, and this is the thickness of the rectangle.
Oh, that makes so much sense now, guys. That's not so bad at all, guys. Do you get this? Like, drop it in the comment below. Do you get that? Like, it's actually not bad. You're simply drawing a rectangle with X, Y coordinates, and you're saying here's the height and here's the width. Like, that is pretty interesting, and it's actually not that bad to understand as well. You can do it. Like, we can do it. You can do it too. Trust me.
If they watch the face detection stuff, this is very similar. They're probably breezing through this right now, just watching us bicker, which is awesome.
Exactly.
But that one was with Kazi, you know, so it's a little bit hard to make fun of him than make fun of Nas, you know.
Yeah.
He's more of a challenge. Anyways, so let's just actually prove that this is working. So we're gonna want to unpack this. So in cars, it was actually an array, right? So there's an array here, and then within the array, there's 2 arrays within the array. So let's just grab out these 2 arrays, okay?
Okay.
So this is going to be array at index 0, and this is going to be array at index 1, okay? Because there's 2 elements in this array, and then there's a list of numbers in there. Okay. So all we're going to want to do is say, I guess, cars at 0. So this would be car 1, okay?
Okay, and why car 0? Why car 0?
Let's just ignore the let's just ignore the second car for now, okay?
Okay.
So car 1 equals cars at 0. So if we print out car 1, car1 just like that. Let's go here, run it again. As you can see, we have just the first car. So 375, 375. That's what we're looking for. And from there, we just want to get the x, y, width, and height. So what we're going to say is we're going to unpack this. I'm going to unpack this list here and say this is x, this is y, this is width, and this is height. Okay?
Okay, seems guys, you're still with us, guys? Guys, give us a thumbs up if you're still with us. This is kind of like, it's all coming together. It is honestly not that difficult. Give us a thumbs up if you're still with us. And Aaron, let's go ahead and start seeing, the result of all this.
Hell yeah. So all we're doing here is we're unpacking this. Okay, so car1, again, is these 4 numbers. And we just want to pack these 4 numbers into these 4 variables, x, y, width, and height. Okay, and then from here, now this code should work. So x and y is the top left point. Okay, we have the image you want to put it on, the color image, not the black and white image. We want to color on the color image, and then put the top left point x, y, and then the bottom right point, which is going to be x plus width and y plus height. Okay, that's how the math works. And then from there, this is just going to be should be red color, so BGR, remember, instead of RGB. So blue is 0. Green is 0, but red is maximum. 255 is the highest value you can have.
So we're creating a red rectangle, basically. That's it.
Yeah, a red rectangle of thickness 2 pixels thick.
Got it.
On this image, at this top left point and this bottom right point. That's all it is, because that's all a rectangle is 2 points.
Makes sense.
And then you just put the rectangle between those 2 points.
Okay.
So let's run this and see what the heck happens.
Guys, ready?
Actually, nothing's gonna happen.
No, come on, man! I'm so excited, man. Aaron, you gotta. The way you bring the excitement.
Bro, shut up. Oh my god.
I'm done with this, guys. I'm done. That's it. Hold on.
So we drew it on the color image, not on the black and white image, but we're still displaying the black and white image. So let's just display the color image, which has the rectangle drawn on it now. Okay, so now it should work. So again, up arrow, and enter. And
hey, let's go!
Got here. So this
got an air horn.
This pew 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 pew.
Do you actually hear that? Do you actually hear that? Pew pew
10 hours for that. That's it.
Hold on, crap. I got the perfect gift for it. Look at that. Oh, look at that. Oh, look at that. You don't see it, Aaron, but trust me, when I see it, it's hilarious.
I'm looking at my code, but I'm pretty sure you're making fun of me or something.
I'm making very much fun of Aaron, guys. Give Aaron a thumbs up in the comments, guys. This is so epic. Look at this. We just detected a 1 car. Like, how crazy is that? With how many lines of code?
Directly in front of you. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines of code.
14 lines of code, guys.
Like 13, bro. Learn to count. Holy shit.
Man, you count, okay? You learn how to count, okay? I count fine.
13 plus 1, 15 minus 1.
Alrighty, guys. Yeah, that's just epic stuff. So, okay, we got 1 rectangle. Now, my question is, how do we get the second rectangle? If you guys know how to do that, drop that in the comments below. And a lot of you guys are like, whoa, let's go. We got Abdullah in the house. We got Harsha, like, yeah. We got Logan. Whoa. We got, oh man, you guys are pumped for this. Look at that. You guys are pumped. I love it.
If you guys are liking this, when this stream is done, definitely go check out the face detection too, because it's similar, but it's a different application, and it's pretty damn cool.
Yeah. Sweet.
But this one's for car and pedestrians.
All right, so let's see how do we go ahead and actually like get
the second car?
Yeah.
Okay, cool. Well, first of all, why don't we just change this, because this is a very easy change. We're currently looking at the first car. Why don't we just get the second car instead by changing? So here, instead of grabbing this first car, we just grab the second car, and let's just draw the rectangle around that. So we simply do that by just changing this to grab the second car instead of the first car. So second car, right? And let's change this to 2 just to be clean about it. And that there should just change all of this to the second car instead, and we'll display it to the screen. So let's just run it.
Let's see it. Ready?
And
hey! Boom!
Hey! Pew, pew, pew. Again.
You say it, and then I play it.
Annoyed with us, bro. We're going pretty slow. But
it's actually funny. Bro, I'm not kidding. Abdullah is like in the comments. Abdullah's like, damn, Aaron and Nas seem like siblings fighting.
Yeah, pretty much. I mean, like, we spend pretty much every day together working on stuff all the time, coding. We practically live together. It's kind of annoying. You know?
I know. I'm annoyed with this guy. That's it. Yeah, I'm annoyed with this guy.
I hate everybody.
Too much. But anyways, let's continue on. We're here to learn, right? Let's go.
Yeah.
Yeah.
So that's the second car. And like I said, in this image, this trained classifier is only good enough to like identify full-on cars from the back like this. These half cars, you can't actually get them. But actually, if you trained something to detect half cars, like the right half of a car or the left half of a car, you could actually find a way to detect all of these as well. But you'd have to train it even further.
Yeah.
And so on, or like the bottom half of a car, something's being. But right now, like this pattern is what we're checking, is the full back of a car.
Right.
Okay.
Right. True.
So now the point is, all we want to do is, instead of manually going through the array like this, we just want to loop through all of them and draw every rectangle on the image for every car that we find. Okay. So that's what I had before. I'm just gonna have a loop, and this is gonna make it super simple. So let's just start from scratch. I'm leaving this here for reference, but just pretend we deleted all this, okay? So what we're gonna want to do is, just like in cars, so in cars, which is an array of arrays, we want to, an array of arrays, we want to iterate through every subarray. So we want to iterate through this first one and the second one and the third and fourth and fifth if there's any of those. So basically we're saying, in cars, you want to take out the XY and the width and the height of every list in there. So actually, I think if I copy and paste this, it'll be a little bit clearer.
Yeah.
So
and I think sorry, let's cut you off. So one important thing, guys, to mention. One important thing, guys, to mention is the way that this works. The way the whole X, Y, W, H, right? This right here is interpolation. Like interpolation, or there's a special name for it. Where basically it will take the object that's in cars, right? It will loop for that, and it will basically grab the X, Y, the width and the height out of those numbers, right? So it will abstract those numbers from those different places. And so that is actually in Python, right? I'm not sure it's called interpolation, what it is.
I don't know, bro, but you're getting super confusing, but keep going.
No, but it's important because they're like, okay, where's this X, Y, W, H coming from, right? But because here's the thing, it's looping through one single object, so that maybe I can do like a screen brush. Hold on, show screen brush. If I can do it, I'm not sure if I can. So right there, right? So this is the first object, right? So this first object is going to be on here, right, in here, and it's going to map to the X to here, the Y to here, the W to here, and the H to here. And you don't see it, but I'm drawing basically on your screen. So So that's the really cool part about Python, and JavaScript actually does this too. But I just want to explain that and so that you guys know. But anyways, let's keep going.
Awesome. Yeah, I have the stream open on my phone. Looks like it's still live.
Yeah, we're good. We're good.
We're in the bottom right. That's
we
cool,
got
man.
300 people in the house,
so
yo.
Wait,
we got 300
which
people.
way? Are you that way? Can I punch you?
What? wait.
I think I can.
Wait. There we go. Go. There you go. Hold on. Hold on. Ready?
Punch him.
Hold on. No.
Beat him up. So who would win?
Man, I wish we could like I wish it's like real, Maybe it can punch you. Yeah, that'd be good.
MMA. You wanna get in the cage, bro?
Let's go, man. I'm ready, man. I'm ready.
Tap out. Have you seen the Fight Club? Have you seen Warrior with Tom Hardy?
Steve is like, please punch him. Wait, punch who? Punch who is the question?
Punch each other. Bro, they want to see us in a ring. It's like Logan Paul and the KSI.
Guys,
let's
who wants to see a live call? Who wants to see a live call like that?
Or Conor McGregor and Mayweather. We can do it like that.
Yeah. But let's keep going. We're here to let's keep going, bro.
Yeah. Anyway, so this is like the longest explanation of a loop ever.
Yep.
But screw it. We're having fun, you guys. I mean, we're having fun. So we're gonna loop over all of these, and then within each of these, we're just gonna unpack the X, Y, W, and H. Okay. So that's all that's happening there. And once we have X, Y, W, and H, we just want to draw all of those rectangles on the screen. We can get rid of this hard-coded. So we're gonna iterate through every pair of coordinates in that list. We're gonna get all of them, and then it's just the same exact line of code here. We're just gonna draw every rectangle on the screen. But actually, what I want to do is, screw it. That's fine.
What?
Nothing. There was a little flavor styling thing I was gonna do, but I'll do it later. Right here, this should work. So if we run this will actually loop through both cars and draw both rectangles, both squares. So why don't we just save this and give this a run? But this. So we just give this a run, up arrow, and hit enter. And ta-da!
Boom!
We looped over both squares.
Oh,
and
shit!
It's like the upper left-hand point. Then we know the width and the height. And then we with the width and the height and this point, we can calculate this point. So it's just boom, boom, red,
Guys.
2 pixel width. Boom, boom, red, 2 pixel width. And
Damn.
that's it. And then
That's it,
for
guys.
video, yeah, that's it. And then for video,
Guys.
you just want to do this for every single frame of a video, over and over and over.
Guys, if we just did this for a picture, guys, who's pumped to see this for a video? Drop that in the comment below. Aaron, are you ready? Are you ready to show this in the video? Because that'd be epic.
Oh, bro, I stayed up all night coding and I'm kind of like bored, you know. But
hey, let's go.
Bro, of course, I'm excited. Stuff is awesome. Like, I'm gonna send this video to Elon Musk and be like, adopt me, please. Like, like Big Bang Theory, Howard or whatever. He wants.
Yeah.
That's basic.
Or pay me money. I just did this for you. You're welcome. You're welcome.
yeah. Oh, yeah, or maybe he'll hire me. Who knows? I mean, maybe one day I'll work at Tesla.
I'm not sure. I'm not sure about that. I don't know why you hired, but Aaron. But anyways, yeah.
Bro, I'll just be a comedian. I'll be a comedian and MMA fighter, like Joe Rogan, and then I'll have Elon Musk smoke weed on my podcast.
Oh man, Abdullah was like, I put all my bets on Nas. Thank you, Abdullah.
Oh really? All his bets on Nas, bro. You want this to go down? I think Nas would be too scared to hit me. I think that's what would happen. Too scared.
Oh, not sure about that. I'm not sure about that.
Whatever.
Okay. All right. Let's continue on. Let's see it.
Let's
go.
move on. So now that we have it done for one image, now it's as simple as getting it into a loop. Okay.
All right.
So, I have that here. It's pretty simple to add it. The only difference is we have to read a video in instead of a video in instead of an image. So let's go up here and actually change that. So instead of image, it's going to be
a video.
Video. Yeah.
Okay.
So let's just paste this. So I have a video on my desktop called Tesla Dashcam Accident. So this is actually real dashcam footage from a real Tesla that was running autopilot and avoided an accident. Okay, so let's just here, Tesla Dashcam Accident. Okay.
Okay, so, and this is just a video basically you got from somewhere, but like from YouTube, I think,
it's
right?
It's in the description. Yeah, it's in the description.
Yeah, gotcha.
Of, like self-driving Tesla. So as you can see, this Tesla almost auto drove and got out of the lane and safely did that. So we're gonna be detecting all these cars in this video. Okay, it's almost over. So that's it.
Sweet.
That's the car I have. I trimmed it to that little clip. But that's the first clip of the video in the description if you can go check it out.
Okay.
So that's the first thing. So instead of an image, we just want a video. Okay. And from there, so all a video is just a bunch of images. So we can just grab out each frame of this video and just apply the same thing as we did to this image to every frame, and then display the rectangles on every frame and just loop forever until the video is done.
So let's do that. Okay, so I'm really interested to see how this actually works out. Okay, cool.
Yeah. I'm gonna.
Hey, what's up, Caesar? Caesar in the house. Hey, what's up?
Why retype code, but you can copy paste it, you know?
Oh yeah, that's the best way. It's best way to code, guys. Always just copy and paste. Don't ever create your own code. I'm kidding, by the way. I'm kidding.
Nah, it's fine. So, I'm just taking a peek here. So yeah, we need a while loop and everything. So I'll type out this one because it's short. This is the first line of code I'm actually coding on the stream. I copied and pasted everything up to this point. Okay, but pretty much what we're gonna want to do is we're gonna want to have a while loop. Okay, not caps, supposed to be lowercase. And we just want it to run forever. Okay, because the video might be, if you're driving a car, you don't know how long the video is going to be, like a real self-driving car. So you just want it to run forever. And then at some point when the car is turned off or like it reaches its destination, you could be like, okay, turn this to false, and then it'll stop reading. It'll stop reading stuff from the camera. So this is just going to run forever. So that's the first step. Now within here, we want to run this same logic on every frame. So again, we had an image here, but instead of an image, we want to get a frame from the video. So we're actually not going to read an image. We're going to be reading a frame from a video. And that's what this thing here is. So let's just copy and paste this. Okay. Let's make sure it's indented properly. So the way we do that is, run forever until car stops or something. Or crashes.
Okay.
Yeah. Yeah, there we go.
Until crashes? Until what? The car crashes?
No, I don't want to get sued by Tesla.
Oh man.
But yeah, so there's in OpenCV, once we have the video here, okay, we have it's called video capture. So OpenCV2.video capture in the name of the file. Then we can just run this, and we can just run read. So all this will do is it'll read one frame from the video.
Okay, and that's a function part of it's a function part of CV.
It's dot
okay
read.
Interesting. Okay,
so
okay,
once you
okay,
have a video capture object here called video, then you can call dot read on that video capture object, which is just the video. So you're just gonna read a single frame from this video.
Okay.
And then once it reads a single frame, it keeps track of it. So when you call this a second time, it gets the second frame. When you call this a third time, it gets the third frame. Again,
got it.
through all the frames, and that's how this is implemented.
Cool.
And what it returns is it actually returns two values. So the first value is if the read was successful or not. Might be actually keep this in parentheses.
Yeah.
If the read was successful or not, and then the second value is if the frame is the actual frame. So like this frame is actually the image, which is just going to be the same as this. So this frame here is actually what we want. Instead of using image and reading an image in, we're reading a frame from this video.
Got it.
So we got the frame here. And then this here is if the frame was read successfully. So we definitely want to have good code and make sure that there wasn't any errors before we try to display it.
Yeah.
Okay.
And the way I see it is like this video.read basically returns an array, which we simply basically map the first portion.
Not an array. So
no.
When you call
a tuple, it's called. No, it's a tuple, right? It's a tuple. Yeah, a tuple. A tuple. It returns a tuple until we map the first. Yeah, okay, fine. Because it's tuple. Because we map the first part of the tuple to here, and then the second part of the tuple is gonna map to here. Now we don't actually see this, but in the background that's actually what happens. So I just want to make sure that you guys understand this. But yeah, anyways, let's keep going.
It's the same thing as here. We're unlacking a forple here. I mean, it's just a four variable tuple.
A forple. I can't even say that.
100 pull. So we're unpacking these four variables out of this array. Same thing. We're unpacking these two values out of this array.
Okay.
And this array is a frame, which is itself an array. It's an image, and then this is a Boolean yes or no.
Yo, Kazi's in the house. Yo, what's up? All right, keep going.
What's up, Kazi? All right, so next, what you want to do is, of course, I'll just type this one out. What you want to do is you only want to handle this frame if it was successful. So you want to make sure you're checking. So here, we'll call this save coding. Use protection, you guys. Save coding. So we only want to continue if the read was successful. I mean, there was a little option on the live stream. It's like, is this video made for kids? I was like, no. I turned that option on hard. So if there's any kids here, you're not supposed to be here. Okay, you're supposed to
okay, you can still learn.
The premises.
You can still learn. It's fine.
But yeah. So here, if read is successful, then you want to operate on this frame. Okay, so I'm just gonna copy paste the rest because I'm lazy.
Okay.
So so if the read was successful, only then do you want to continue. So then at that point we'll get the frame, which is here, and then we'll convert it to grayscale. Okay.
Interesting. Okay,
because if the frame didn't read correctly, if this returns false because the frame is broken, you can't actually call this. This next step is this needs to be a valid frame for it to be converted to grayscale. So if this is an invalid frame because the read screwed up, then you just want to skip this and just break out of the loop. Okay.
All right. When would it ever be a non-invalid frame?
When the last frame of a video, it'll automatically end the video by itself automatically.
Okay, gotcha. Okay.
If you error out or if you manually say, hey, stop this video.
Yeah. By the way, guys, we're completely kidding about the kids thing. If you're a kid, it's okay to say. A lot of you guys like, oh, my kid, I'm a kid, and I'm a kid. I'm a kid. I'm like, guys, it's okay. We're completely joking about this stuff. Guys.
I mean, it's already far gone at this point.
Yeah.
Welcome, kids. Welcome to Willy Wonka's Chocolate Factory.
Oh God. All right, let's continue. Oh man.
Hi, Mom.
So where we at?
Yes, it's gonna break out. So once we have the grayscale frame here, the same idea of you want image and black and white, we can actually change this to black. I'll just keep it grayscale. That's the proper term instead of black and white. And then we have a grayscaled frame from here. Okay.
Okay.
And why don't we just display that. So
okay, let's see it.
Actually, let's comment all of this out because it's gonna break something. Okay.
Okay. Okay.
And then let's just. This is not going to do anything because it's not displaying anything. So we do need the display code again. Okay. Remember the display code. You want to display the current frame. In this case, it'll be grayscaled frame instead of image. Okay. Instead of image, it'll be grayscaled frame. And it'll only get here if the frame was successful. Remember that, you guys, because else we break out of this while loop and then we don't even get to this code. So it avoids the errors.
Let me ask you a question. We have Logan actually asked a question. Would it be better would it be better to only would it be better to only use every other frame for speed?
Yeah, you could do that
Would it
too.
be?
Of course, you'd have a little bit lowered quality. You could even lower the resolution of each frame to go even faster because the resolution of an image is halved, like if this was kind of blurry, you as a human could still tell this is a car. If it was super blurry, you could probably still tell it's kind of like a car. You could kind of make it out. You're like, okay, this is a highway and a car. So there's many things you can do to speed it up. You can downscale it. Actually, I'll touch on that quick. If you go to detect multiscale, that's what scale factor is. Actually be like, okay, blur this image a little bit to make it faster. You can like increase the factor.
Oh, interesting. Okay, that was good. I think that was a good question.
Yeah, like if you have 4K footage, it's going to be kind of like really hard to run all the algorithms. But if you scale it down to like scale 4K down to like 360 pixels, 360p or 480p, it'll be a lot faster and it might still work. So you can
and that's probably what Tesla does as well, right? Because they probably scale down the image so that they can process it much faster, right? Because you can't process like a 4K image, right? Yeah.
There's some trade-off between having accuracy with high resolution images and also speed, because when you're driving a real car, you need to have real time feedback. So they go as high as the accuracy can be while keeping it real time, because speed and accuracy are both important. It's like, oh, this car's gonna hit me, and then 2 hours later you don't turn. You're still they're gonna hit you.
Yeah.
You gotta turn like
too late.
video. Yeah, just like this video playing. Like this guy crashing before. Remember, like Tesla here, it sees this, and as soon as he comes over, he's instant.
So it's quick. It's quick. It's really quick.
Yeah, it's like instantaneous. So there's a trade-off of accuracy and speed there.
Yeah. Okay. Cool. Sweet.
Moving on. So from here, we're going to display the grayscaled frame, and then of course you need to have this, because this will just display for a split second then disappear. So we want it to stay on the frame, the current frame, and this actually tells us stay on the frame for 1 second or 1 millisecond or something like that.
Okay.
And then it'll loop up and show the second frame. It'll read the frame. It will, if it's successful, it'll turn it gray, and then it'll display it, the grayscaled frame, and then it'll wait a second, 1 millisecond, and repeat. And it'll do this for every single frame.
And so this is basically you're not creating a video.
No, I am creating a video.
Okay, you are.
So this is going to be a black and white version of that same video.
Got it.
The video that
okay. I get it. Okay.
You know what blue is, Nas? You know what blue is, right?
No, I don't know what blue is. Is it red?
All right. Why do you have to kill every joke, bro? Like, it turns unfunny when you say it. Anyways.
Hey, I'm laughing. Boom. Hey, look at that. Oh, this is like it's like sped up. Why is it so sped up?
Because we changed it to grayscale, so it can compute it faster.
Oh.
See how that?
Okay. Interesting.
Yep. So it's going faster, and this is the whole video. The video is going, and then when the video ends, it automatically closes.
Guys, do you understand? Like, and drop in the comments below. Do you understand how it is even like displaying that specific video, right? Because look, like, drop in the comments below if you understand like the way this is working, right? The way I understand it personally, is literally, right. If we have, the way I see it is like, yes, we have a video, right? We have a video right here, and what we literally do after that point is we unpack the video and we go through frame by frame, and then we output that frame again to create yet another basically video. It's just that this time we added the video simply because we changed it to grayscale. So every single frame, as you guys know, every video, right, is created with frames, right? What we do is literally take that frame, we convert it to grayscale, and then we show it again. And again, you went from video to another video, except this time it is grayscale. So I just thought it was really interesting. If you know what I'm talking about, like, drop it in the comments below, because that's mind blowing to me, you know?
Yeah, what he said.
Yeah, what I said.
What Nas said. All right, guys. So we have the grayscale images here in a loop, and it's properly looping through every frame of the video. Now all we need to do is run the detection code again, and then from there, once we have the detection code, we can draw the rectangles again on the colored image, and then display the colored image, the colored frame, instead of the grayscale frame. And that pretty much does it. And then at that point, that we also want to introduce pedestrians and use different kinds of videos with both and mix them together. But that's the last step. So let's go with that next. So the next thing is, once we have our grayscaled frame, we want to run the car classifier on it. Remember, we have our oh, I don't even have it. It's I deleted it, didn't I?
What?
Car tracker. So let's get this back. Okay. So let's get our car classifier back and paste it up here. Once we have the classifier file, then you want to feed that into Cascade classifier, and we have a car tracker now. So this is the pre-trained data that we downloaded from this file.
Okay.
Now with this car tracker, we can do the same thing. We can just go down here and copy paste the code because laziness. And detect cars.
Especially for Aaron.
I mean, copy and paste as much as you can, because what's the point of typing it out? Like, you want to tackle bigger and bigger problems. This saves time. This is literally cutting the stream length in half, and we can fill it up with jokes.
Yeah. Okay.
So now we want to detect all of the cars in this current frame. So again, we have our car tracker up here, auto highlights for us. And then again, we want to detect all of our cars, regardless of the scale of the car match. And then what we're feeding in is the grayscaled frame, okay? Because this is the current frame in black and white, and black and white is much faster.
Okay. So and if you just so you know, guys, like when we say frame, a frame is simply, hold on, let me show you. A frame is simply just a still image. It's just a image from the video, right? That's why it's able to detect the car. So it's not actually moving. It's just one image. Right, that's the interesting part about it, right? We took the image out, so yeah, let's keep going, and that's how we were able to detect, detect those cars in there.
Hell yeah, what he said.
Yeah, what I said.
What he said.
Hey, no, not hitting me. Let's take it outside, okay? We'll take it outside next time.
When are you getting back to LA? After this Corona thing's done, I'm back in LA in September.
Are you kidding me, man? Guys. Man, this is gonna be a live stream, okay?
I'll cough on you, bro.
What? That's not gonna do anything to me. you can cough at your own pace. Cough at your own plows, Don't cough here. Don't cough in LA.
This is the stupidest stream ever, but whatever.
Oh man,
we made like $2, right? Like, people have donated to us.
I know. We made €2.
Make one more $1, but we can go get coffee. You can get the $1 coffee from McDonald's.
Hey, let's go. Let's go.
Anyway, so yeah, we have the cars here. And again, remember, this is an array of a bunch of different coordinates of the cars. So why don't we actually print that out? So let's print out cars. And each time, for each frame, you're going to see a bunch of different stuff print out. Because every frame, there's multiple cars. So you're going to see a bunch of stuff print out in the terminal forever, because it's a loop. So let's actually run this, okay? And as you can see, we have all the cars detected in each frame. We just haven't drawn them on the video yet. But you can see them all getting spit out here. Top left point, bottom right point, the width, and the height.
That's insane.
So the width and the height is always the same.
That's insane.
By default. And then
you can see some of them. And you can see some of them don't even have a car.
Yeah, they don't have cars. So it read the frame correctly, but there is no car in that frame, and it just skips it. And then once it gets to the end, when there's no frames left, this actually becomes false because it can't read anymore. So this actually does error out. So it actually does get to this break statement on the last frame of the video, and that's what you're seeing here.
Gotcha.
The last frame happens, and then it gets to the code completed. Remember?
Got it.
That's why it's good to have this, because you can see.
Got it.
Little Aaron there. Dope. So now last step is just drawing the rectangles on the colored image, just the same as with the image. Okay, so pretty simple. We don't need print cars anymore. And of course, on the copy paste master.
Of course.
Go to this one, right? I think so. Rectangles. There we go. So Pretty much this should work now. Only error is that this image is not an image. It should be actually frame. It should not be image because we're not doing images anymore. We're doing frames. So we just pop frame in there. So it'll iterate over every single car it finds in each frame, and then it'll just draw a rectangle around that car on that current frame. Again, with a red color and a 2 thickness.
Got it.
So let's just run this and see what happens. Let's run this, baby.
You guys ready? Are you guys ready for this? You guys ready? All right, let's see what happens. Actually, okay. Okay. Oh, dang.
It is not working, and
oh no! Oh man! Oh no! Oh no bueno! This is not good. No good. No good. No good. No good. Guys.
Reason being is we are still displaying the grayscale image. We actually want to display the frame because we drew the rectangle on the frame. So
okay.
Little bug there. Actually,
did you guys see that? Did you guys get that? Did you guys get that? I hope you did.
Yeah, because it was black and like when I ran it, I'll run it again.
Okay.
Oops. It was. Oh, okay. So now it's working.
Oh, hold on. You guys, are you guys ready? You guys ready? You ready for this?
Oh, no,
you ready for this?
It's black and white.
No, come on.
Because when I ran it, yep, still black and white. Okay, because it says grayscaled frame here. But if we're displaying the colored frame, which has the squares drawn on it, then I can save this and display the frame. So let's go back here.
This is normal frames right now.
Cancel this. Clear again.
Okay.
Now we're displaying the colored image with the rectangles drawn on each frame over and over and over again. Okay.
Gotcha.
This is within the while loop because you want to make sure you're drawing. And
all right, you ready? Ready? Hey, let's go.
So it's not perfect, but I mean, hey, it's not random. You can tell that it's more correct than it is incorrect. Like it's not just random squares all over the image. It's pretty damn accurate. Like we think about it, this is like 80% accuracy. That's not nearly good enough for like real world scenarios in cars, but we're 80% there.
Bro, that is insane. This is some magic. Guys, seriously, like this is some magical stuff. Like how pumped are you to see this or to even build something like this? Especially the fact that we just built this. Like, guys, we literally just built this in like what? In how many? In what? I mean, an hour and a half, 2 hours maybe. Holy shit!
I mean,
holy
it's
shit!
Not the code, bro. Chill out.
Guys, I only have one gift to show how I think we feel like right now. Are you ready? Ready to see this? I'm sorry, Aaron, you don't see this, but they will see this. So only one way. Only this way. Oh yeah. Peace out, guys. This is how we do it.
All right, let me check.
Drop in the comments, guys. For some, you'll see it. There's gonna be a small delay, but that's all right.
Holy. Who is that? Just some random. Random girl in the crowd. That's funny, bro. Oh man,
this is hilarious. Logan's like, this is awesome. Belly, this is epic. We got Logan. Wow.
I mean, we haven't even gone to pedestrians yet. How do we detect pedestrians and cars in the same
video?
Oh
wait, so we haven't got to pedestrians yet?
Nah, bro. We haven't even touched that yet. We still got to download that classifier and get that running, and we have to scan across every frame for both of them. So that we can detect pedestrians and cars.
Okay.
And you could also train it for anything. Like you could train it to detect NOS, in videos and stuff if you wanted to.
That's important. But, detecting NOS.
I mean, who would want to do that?
What? What are you talking about? Who wanted? Everybody.
Okay. Yeah, guys. But what I'm gonna do is I also want to show you some other videos. So I actually have a bunch here.
Okay, let's see it.
I have a couple other videos that I pulled out from YouTube. This is all from the same video linked in the description. There's it's like within the first 3 or 4 minutes. All 3 of these clips are in that video. I skipped some of them because it was like dark and rainy and it wasn't performing that well. But I mean, this is pretty good performance for stuff you downloaded off the internet. Of course, if you trained your own Haar classifier extensively and you let it run for like 3 weeks and you trained it, then that have really, really, really good results. But these are just ones I just downloaded off the internet. Like I said, like the Car Dataset. This was created by people at Caltech, the California Institute of Technology. But these cars all look old, so this must have been done in the freaking 80s, So like this is old data that we're using. But they did use this to train their Haar Cascade. But we could go out and take our own thousands of images. But I mean, I'm not gonna do that. Sorry, guys.
Okay, yeah. That's too much work. Why redefine the wheel when it's already defined for you?
Yeah. It's like use a library because it exists. But
hey, we got Robin donated 100. I don't know what money that is. 100 not euro something. I don't know how much money that is. It's like Robin. Yeah. Anyways, 100 something. Thank you, Robin. Appreciate it.
Appreciate. What was his name? Robin.
Robin. Yeah.
Appreciate that, Robin.
Yep.
Appreciate that. Now, let's continue on. So the next step would be, oh yeah, I was gonna show the other videos. So let's just change up this video. So this one is actually one where, the Tesla self-driving car actually detected and avoided a tumbleweed. So it was a huge thing on the road, and it actually avoids it. So let's run this footage. So this happens here. It's running in color, and then boom, tumbleweed.
Where?
And it just dodges it. Bro, you missed it.
Oh, I missed it? Oh, man. Oh, there it is. There it is. Oh, dang.
So
that is insane.
Yeah, and in an actual video, the guy's talking, and then somebody behind him actually hits it. So I don't know, but hopefully they're okay. But it's just a tumbleweed. It'll damage your car, but unless they swerve, that might cause an accident. But if they just hit it, it should be fine, I hope. And yep, so that's another video from that clip. And then here's another one. I just pulled this off, like randomly off the internet. I just did Tesla dash cam footage, and I just found this video. And then here, this last one is some highway footage, also from that same clip. So feel free to go watch that same clip.
That's insane.
Here you go.
Damn. Guys, how cool is that? Like, how cool is that? The fact that we just created a system that, you know, I mean, I would say Tesla-like. I mean, I would say it's not perfect, right? But the gist of it, and that now you understand kind of how it works. That
the not
to me
perfect
is
thing, I want to point that out. See how this is constantly saying it's a car? Because think about that. There's the dark window, the light bumper, the dark shadow. So it keeps mistaking this for a car because it has that same profile. Remember the Haar feature of light and dark, dark and light, and then light and dark. Remember?
Yeah.
From here. So this matches these things. This thing kind of looks like this because there's a dark window, a light bumper, and a dark shadow underneath the car. See? Dark window, light bumper, and a shadow underneath the car.
Got it.
So that's why it's misclassifying this. It's a false positive.
That's why it's not a perfect system, right? It needs a lot more classification basically for this.
Yeah. I mean, if you ran it super extensively, you could detect every single car in the single image perfectly, but it would take forever to run. It wouldn't be running that fast.
That makes sense.
Uh-huh.
Okay, cool.
And so that's it. So these clips are in the description. You're gonna have to download the YouTube video yourself, and then trim out the clips, but you can definitely do that. And then just name it whatever you want. It's an MP4 file, so make sure you download the video. Got it. That's really it. So I had those three examples. Oh, one thing I did forget to show is nah, that's okay. It's too late.
No,
I already
fine.
showed them with the image thing.
Yeah.
With that video.
So what should we do now? So what's the next step, Aaron?
Well, why don't we detect this, the thing I started off with, the demo, where there's cars and pedestrians.
Okay.
How do we detect both in the same video? I don't know if you guys can hear that, but there's audio going. But this is the original footage I showed. So now we want to actually introduce pedestrians as well.
All right, let's do it, bro. We got cars. Next thing is pedestrians. Then we got cats and dogs. No, I'm kidding. We're just going to do pedestrians, I think.
Yeah, pedestrians.
So, yeah. Who's pumped?
I mean, we could do cats and dogs next time, but I mean, I think self-driving cars is cooler.
Yeah. Maybe next time. But yeah, if you're pumped to see that, let's get into it. Actually, drop it in the comments below, too. Drop it in the comments below.
Yeah. So what we're going to want to do is we are going to want to actually download another classifier, okay? So we have a car classifier, and that's what's doing all the work for our car classifier. But we're also going to want a classifier for pedestrians and have both of them running, okay? So how we do that is we're just simply going to download another pedestrian classifier. So again, the link is in the description. This one is actually supplied to us from OpenCV by default. There's a Haar Cascade file, XML file again, called Haar Cascade Full Body right here on my desktop. Open this up. So it's the same exact thing. Again, it has all these crazy numbers, and it goes on for thousands and thousands of Haar features, and it filters through all of it. But this series of Haar features kind of matches up with what a pedestrian would look like, whether they're standing or walking or running or whatever, or even like on a scooter. It would still be able to detect it. Okay.
Yeah.
So a bunch. You can see it goes on forever, and it takes forever to train this and actually generate these correct numbers, just capturing the relationship and the patterns.
Avil is like, wow, this is amazing. Wow. Oh, Robin just donated another 200. I think it's called V dollars. I don't know what it's called, but another 200. Dang.
I don't know what $V are, but it sounds like a lot. Thank you, Robin. Appreciate that.
Appreciate it. Oh wait, well, no,
Okay.
he asked a question. He asked a question actually. His question was, and I can't put it up on the screen because I don't have it. For example, for some reason it didn't actually show up on Ecamm. But his question was, if a different IDE is used, will speed and accuracy get impacted in output?
A different IDE?
Yeah.
No.
No.
Reason being is this IDE is just a code editor. It just makes the colors nice. It makes strings orange. It makes comments green. It does all that nice stuff. But when you're running code from the terminal, it's literally just getting this raw text file, this raw Python file, which is just a text file that has Python code in it. And then it runs that Python code. So like I could even open up this Python code. I could open it in TextEdit. Okay.
Got it.
This is the code we're running in VS Code. So it doesn't matter what you're using to edit it. It's just running this raw text code. It's just translating this to ones and zeros that the computer understands. So actually what's running all that stuff is literally just this text file. This text file is generating all of this tracking. So it's reading the file name, getting all the stuff. It's making the classifier. I mean, you kind of can't see, but like.
Yeah. So to answer your question quickly, no, it would not, basically, it would not matter. It would not impact any processing or anything like that.
At all. Zero.
Yeah.
Zero.
Sweet.
And so let's just move on to pedestrians. Okay. So I have a video here, a dashcam of dashcam pedestrians, which is this video of a lot of pedestrians here. There's not so many cars because I want to show this first. Okay. And what we're going to have to do is we're going to have to actually get the pedestrian classifier as well. So actually, let's just grab this. And paste this here. So classifier file is car detector. Really, this should be called car tracker. So actually, let's change that. So it's only popping up here and here, but let's change this to car tracker. All right. Change this to car tracker. So now it's a little bit clear that this is a car tracker. And well, actually,
what? We have two different trackers, right? One is a car tracker, and then
I screwed it up a little bit. So we should actually, no, this is car tracker down here. So this should be car tracker file. Oops. And this should be car tracker file. Okay. So ignore this stuff. Let me just delete it because it might be a little confusing. So let me ignore that for now. So what I did was I changed this name to car tracker file to be a little bit more descriptive with the name. And then again, we're just popping this car tracker file into here to get the Cascade classifier, which gives us our car tracker. Now let's repeat these two lines of code, but for pedestrians. Okay. So for us, it's going to be pedestrian file tracker. No, pedestrian tracker file equals this. Okay. So it's the same thing as this line, but here for pedestrians. Okay. We have a different XML file for cars, a different XML file for pedestrians. And let me just comment this again. And actually, I think it'll be better to keep these together. So our pre-trained car and pedestrian classifiers with an S. Okay, so we have both of them here. And now we can have our pedestrian tracker. So this would actually be, this is where we actually, I don't even have to do it. I can just copy and paste this here, the Cascade classifier. Okay, so pedestrian track is going to be this. I'll just type it out this time. So CV2 and Cascade classifier, and it auto completes for me. And then from here, then you want to get the pedestrian tracker file and paste that in here. So that should make sense. So we did it once for car file, car tracker. Now we have pedestrian file and pedestrian tracker. All right. So we have both. Now that we have both, all we want to do is detect both in every frame and draw rectangles around both in every frame. Very straightforward. So the thing we're going to want to do is, of course, for every frame, we want to run the loop. We want to read the frame. That doesn't change. But and then we change it to grayscale. Okay, that doesn't change either. Once we have the grayscale image, then we want to detect cars and pedestrians. Okay, see that? We're only detecting cars right now, but we want to detect cars and pedestrians. So that would be something like this. Okay, pedestrians equals pedestrian tracker. Okay, pedestrian tracker dot again detect multi-scale. because you want to detect pedestrians of all scales and all sizes. And we're just going to fit in the grayscale frame. So this is just exactly the same code as for cars. We're just using a different classifier, okay? Which means it's going to give us different coordinates, different squares of different whatchamacallit.
What do you mean? Different squares, basically, different squares for like pedestrians and stuff like that. Oh yeah, I get it. Yeah.
So this is a list of cars, and this is a list of pedestrians. That's all it is.
Okay. Yeah.
Okay.
So if you guys don't know, it's basically we got pedestrians, so we're detecting different pedestrians. We're using one classifier for pedestrians, right? And then we're using another classifier for cars, right? And that again is that is detected through where? Through here. Well, I don't know if I can draw, but yeah, you can see one for car tracker and another one for pedestrian tracker. So that is really cool. Okay, all right, let's keep going.
Yeah. And once we have these, then we can just repeat the same exact process with the rectangles for drawing the pedestrians that we do for drawing the cars. So it's literally the same exact thing. I'm just going to draw the pedestrians in yellow instead of red. Okay. And that's really it. Okay.
That's it?
Yeah. That's
man.
It.
All right.
So I just copied and pasted it. The only difference is for cars, you want to iterate through all the cars again for those points. Then you want to draw on the current frame, the current color frame, top left point, bottom right, the top left point, the bottom right point, and make it red with thickness of 2. Now for the pedestrians, we want to, again, we can just reuse the same variables of x, y, w, and h because at this point we're done with them, so we can just overwrite them. X, Y, W, H. In pedestrians, so again, this is its own list of pedestrians. Then we want to draw a rectangle, again, on the colored frame, top left point, bottom right point. This time we want to do yellow, so this is the color for yellow. So if the green and the red are maxed out, it becomes yellow. I don't know how that works out.
And again, guys, it's not so much about like, red, green, right? We simply just pick those colors because why not? You just pick the random colors, right? But you can pick any color you want, right? That's those 0, 22, 55, and 2. Yeah, this would be completely white. So you can pretty much change it to anything you want.
Yeah. Unimportant detail. I mean, to be honest, on Tesla, when they're doing self-driving cars, they don't even bother drawing the rectangles around the car because from this point, they just know where the car is, and the car doesn't need to see it. I mean, the car already does see the other cars or the pedestrians with this data. It doesn't actually need to draw a rectangle. No, the rectangles are just for humans. So this
Logan in the live stream, man. Logan, appreciate your freaking energy, bro. Logan says like, I love this live stream. This is so much helpful. Much nicer way to expose myself to OpenCV than reading documentation.
Oh, hell yeah.
Yeah. Avel is like, Aaron, you're crushing it, buddy. Keep it up, bro. You're crushing it, bro. What?
Watch our video and our jokes.
Let's just read this through the live stream. That's all we do. Just read documentation.
Cascade classifier : detect multi-scale. Detects objects of different sizes in the input image. The detected objects are returned as a list of rectangles. I mean, this is exactly what we're saying, right? It's it sounds very nerdy. You detect objects, in our case, cars and pedestrians of different sizes because it's multi-scale.
Okay.
And the input images are framed.
Yeah.
The detected objects are returned as a list of rectangle points, and then we just draw them. So that's it.
All right, let's see it, man. Guys, I'm so excited to see this. Let's go, guys.
We're gonna see a bunch of pedestrians because the video we're using, there's a bunch of pedestrians, but not very many cars. Like I think there's like one car here, but all these pedestrians will all get identified. Okay. So let's just go for it. All right. Wait, did I delete something?
Ready? What'd you delete?
Oh, I deleted the whole loop. Oops. I was like, wait, where did the code go? Yeah.
Did it not work?
No, I didn't. I deleted a bunch of the code I just typed out, and then I didn't even run it yet, but I caught myself.
Okay. All right.
Let's just do this nastiness.
All right.
And let's run the Python file. So car and pedestrian tracking.py. And boom.
Oh, shit.
See? It's doing a decent job of detecting the pedestrians.
Guys. Holy moly. Hey, bing, guys, this is a wow. Okay. Holy shit. Wait, okay, this is just pedestrians right now. You guys ready? Check this out. How cool is that? Guys? Drop that in the comment below. That is sweet. Oh man, that
Yeah,
is
man.
amazing.
All right. So
Wow.
that
Is that it? That is that?
that's pretty much it. What I want to do is I want to add a little bit of flavor to something, and then
All
add
right.
a couple other safekeeping things that we're gonna
Okay.
go
Okay.
over,
All right. All
and
right. All
then
right. All right.
add a little bit of style, and then run it on some new videos, and then that'll conclude it. Pretty much. Pretty
That is
concise
my
app.
that's my
It's
face right there, guys.
not too crazy.
This right here is probably your face right now. I'm kidding. I'm not kidding. Like
But
make that face right now, and as you're watching the video, make that face right now. You know the
shit.
face I'm talking about.
Oh, the cloudy with a
Oh
chance of
man,
meatballs. I just saw it pop
Claudio,
up.
is that okay? Yeah, yeah, exactly.
Come on, bro. Didn't you grow up when that came out? We were like 12 when it came out.
Hey, this is still an awesome
So,
movie, bro.
yeah,
Who doesn't watch
it's an
that?
alright
Come on,
movie.
come on, man.
Incredibles is better. Shrek
Come
is better.
on, man.
But
People are like, this is
yeah, so what I want to
fire.
do, guys, what I want to do is, I don't know about you guys, but in the thumbnail of this live stream, I had like
Mhm.
a little quirky styling thing where for
Mhm.
the cars it was red and blue, and then for pedestrians it
Okay.
was just yellow. So I just want to chuck that in. So all I did was I'm just drawing two rectangles here instead, just for a little bit of flavor, and just pop
Okay.
that in. So I actually for each car I actually draw two rectangles, one red rectangle and one blue rectangle. So this is
And
the
what's the,
red.
what's the reason?
This,
What's the reason for that? I'm just curious. Just
Hmm?
because you want to be fancy?
Yeah, I just want to be fancy, bro. Come on.
Okay, fine. I mean,
So
okay,
all I did
alright.
was I just drew a
Aaron
red
out here being
rectangle
fancy.
here with
Mhm.
the red channel max, everything else closed, and the blue channel
Mhm.
here, 255 enclosed, but I offset it by 1 and 2 pixels a little bit so you can see it changing.
Mhm.
This is
Mhm.
like this is completely useless code. It's just for a little bit of front end development.
Mhm.
But when you run it, you can see, I mean, there's not that many cars here, but you can see
Yeah, yeah.
whenever a car one pops up, there's a little bit of blue as well as red.
Oh
So
man.
a little bit of
Wait.
flavor.
Put that image in the center. Put the video in the center.
Oh,
Oh, never mind. Just keep going. Never mind. Just keep going. You're fine. You're fine.
like that.
Guys, how cool is that? How cool is that?
Oh,
You got okay. That makes me excited, bro. Honestly. All right. Shit. All right.
calm down, calm down.
I love
All
this
right,
AI
well,
stuff. I
that
used
is
to. I
that.
actually, guys. Actually, interestingly enough, I used to do AI stuff as well for a company, but we did AI. So interestingly enough, I'll just tell you a really quick story. I did AI for for actually detecting signatures, detecting fake signatures. So we use a
Mm.
similar. We also use OpenCV as well, and we detected if signatures were fake or they were real. And we had, I'm not kidding, we had signatures from like thousands and thousands of like images, and we were able to detect like if the images was like real or not. By the way, I just want to let you know, Robin, seriously, holy moly. Thanks again. He donated
Donated what money?
400 V something. V
Thanks,
dollars?
Robin.
I don't even know. I don't know. Robin, you're the best. Thank you. Appreciate it. Always appreciating donations, you know? Oh
Dang.
man. Yeah.
Hey,
But
Robin's on
anyways,
fire.
yeah, Robin's on fire. Robin's like, yo, let's go. We just hit the goal.
All right, we're almost done, you guys. Just a couple more things, and we can run on some extra videos, and then we can just let it run, and
Yeah.
that'll complete the app, you guys.
Yeah.
So, last things I want to do are actually, when you're running the video, I want to be able to actually quit the window, with a key.
So,
So I
right
pop
there,
this little
guys.
code
There's
in here.
Robin donated right there. Appreciate it, bro. Right there. You guys can see it. Yeah. There we go. Hey. All right, let's continue on. By the way, I don't see you. Do I see you? No, I don't see you. Oh, there we go. There, now I see you. There you are now. There you go.
Am
Now I see you.
am I good?
No, you're good. You're good. Keep going. Keep going.
Okay, got it.
Yeah.
So here on the code, I'm just gonna copy and paste in a little housekeeping here. So if the Q key is pressed, Q for quit, then I want to break out of this loop, which means it'll abort the video stream like whenever you type that key. So the key for lowercase q and uppercase q are 81 and 113. You can look that up online. Every letter and every keyboard button has its own number, and you can just find it with a Google search. You just be like lowercase q and uppercase q. What are the numbers? You just put that in, and once you have these numbers, then if either of those are pressed, if key equals that or that, then it will just break out and we'll just stop.
Okay.
And
Got
the
it.
key is automatically whatever you press from wait key, because it's waiting for a key. You see what I mean? And so if it's waiting for a key and you press Q, automatically it goes to the next one, and then key becomes Q, and it'll match. And that's really it.
Cool.
Okay, last thing is you want to release the video capture. So
Wait, what is the release? Why release what?
So video here. Our
Okay.
video is the video capture object that we got from our video file.
All right.
And it's constantly reading a file. Okay. And so video is constantly reading a file. So when we're done doing it, we just want to release reading of the file. So it's just
Got
like
it. So it's like okay,
a stream of data coming in.
So basically, it's like stop reading the file. You're good. That's what it's saying.
Yeah. It says we're done reading this file. Just release all resources from trying to read this file, so we're done. And that's really it's just a cleanup, like a memory management thing.
Yeah.
And that's really it, you guys.
Guys,
I don't think I missed
pretty
anything.
much it.
That's everything I had planned. We can
that it?
Change this to
let's see.
Self-driving car.
All right.
There you go.
I'm excited to see some videos, bro. Let's do it.
Yeah, let's go here and let's run it again. Your name
guys
key
ready?
is not defined.
Are you guys? Oh, what key?
Oh, there was an error here. It says key is not defined because.
Do you guys know what the key is? You guys know what the problem is? Drop in the comment below. You guys, huh? I think I know. I know what it is. Do you know, Aaron?
Yep. Of course I do not.
Are you sure you do? I'm not sure. I'm not so sure about that.
So, yeah, the problem is that this key variable doesn't actually exist, and the reason for that is we didn't actually set that equal to here. So this does wait for a key to be pressed, but it never captures that. So we got to capture it in key, and now when key is pressed, then it should work.
Okay.
So
dope.
Back here, let's just clear this out so it's nice and clean. Run it again, and there we go. So it's going.
Hey, okay.
And if I press the Q key, it should quit.
Sweet. Okay. Cool. All right. Damn, guys, this is crazy. Guys, this is amazing. Holy shit. Like, we just created a system that detects pedestrians and cars within, an hour or 2 hours. With some training data.
That's it.
That we didn't even create.
No,
we just borrowed. We borrowed.
Yeah, but I mean,
we borrowed.
You can download all this off the internet. Like you can download XML files for anything.
Yeah.
You can probably download an XML file for a cat, for a dog, for a water bottle, for a football, for anything. You can download. Somebody else, probably somewhere on the planet, has trained a Haar Cascade file for you somewhere and uploaded it somewhere. You can probably download it and you could probably use it and do a very similar thing depending on how well they trained it. And of course, you can train your own too if you want to go that route. I'm sure that exists on Google how to do that, but that's a much longer process. You have to find all your own data. Yeah.
Cool.
Your own images.
Sweet, guys. So let's keep viewing some more videos. What is we got?
Yeah. So we have a couple more.
All right.
So that was like a pedestrian heavy. Let's run it again. This was a very pedestrian heavy video. Okay. Lots of pedestrians.
So what do you guys see? What do you guys see? You guys see just a lot of pedestrians walking, right? And it's able to detect those systems. And if you think about it, right, what would a system do? You can now, since you can now detect something, you basically can now tell a system, hey, if you detected it, stop the car, or hey, stop anything you want. So that's kind of why this stuff works really well. You know what I mean?
Yep. So let's just do this, okay? So another video file I have is dashcam cars and pedestrians because it has a little bit more mix of both. This is actually the video file that I showed you at the beginning, okay? So how long is this video?
All right. Okay.
Yeah,
so that's a different video.
It's like 4 minutes long.
All right.
So let's go. And let's just let it run. So this is the video I showed you at the beginning.
Oh, man, that's cool. Damn. Guys, give us some fire in the comments, guys. That is cool. All right. Look at this guy's walking. What is that? You see how it's able to detect the little pothole at the bottom? I thought that was interesting.
Yeah, it's not perfect, but
yeah, of course.
It's better than nothing. Better than random. Much better than random. And there we go, you guys. If you can see, it looks a little bit slower because it's doing double compute power.
Yeah.
You see? So you can think about it for Tesla, like a real self-driving car. Think about it. It has to detect pedestrians. It has to detect cars. It has to detect signs, all different kinds of signs, speed limits, stop signs. Has to detect traffic lights. Has to detect different nighttime and daytime things. Has to detect rainy conditions and non-rainy conditions. It has to actually send those values to the car to brake or turn accordingly. There's so much going on. So this is just scraping the surface. This is pretty cool, but this is just the very, very surface of what's actually going on.
I mean, in general, honestly, it's like it's crazy, right? Because the amount of data that it has to process, right, in terms of pixels, right, in terms of how fast it has to do it as well, it's insane.
Mhm.
But you can see like I think, guys, what's really interesting. And hold on, actually no, let's keep watching the video. As you guys can see, right, the really interesting part is like the fact that all we simply did is, if we divide a problem, right, into certain little parts, right, into small little parts, right, which is, how do we divide this up? Like, drop in the comments below, how do we divide up this huge problem, which is we wanted to detect, right, like pedestrians and cars in a video. How do we divide that? Well, first is we found a lot of training data. That's part one, right? Two, right, we first did testing on the pictures, individual pictures, right, and then what happened is, once we got the pictures, right, we were able to bring in a video. We were able to take certain pictures, right, every single frame from that video, and then next thing you know, we're able to display it back to the user. So by dividing this up into 3 or 4 different parts, you literally just are able to solve this humongous issue, not an issue, but this crazy epic, thing in an hour or two. Do you guys see that? Yeah, just drop that in the comment below if you agree with me. Like, seriously, because that is, to me, is insane. A lot of people think that this is crazy stuff, but honestly, you just some work and you're good. Am I right?
Yeah, man, look at it go.
What
it's
goes?
A bit slow there. I think it's slow motion.
Yeah.
I mean, it's detecting that sign wrong, but it's getting the girl. It's getting some of the cars in the back.
Yeah, right there.
Some of the pedestrians a little bit.
Yeah.
Yeah, and there's ways you can optimize this. You can be like, okay, if there's two rectangles in the general same area twice in a row, you can kind of be like, okay, there's a higher chance that this actually is a pedestrian. It's not just a random thing, a random detection.
So hold on, I want to ask you a question. So somebody asked a question. Actually, George asked a question. How can I get this source code? If I can take a look at it, please, so I can take a look at it.
I'll post it in the description. I'll upload it to a Replit or something, Replit.it, and then you can download the code if you didn't type it out yourself with us. Yep.
Cool. Yeah.
Granted, it won't work in Replit. You're gonna have to download OpenCV, the OpenCV package within Replit itself, and run it there. Mm-hmm. But you can just get I'm just gonna post it there for code reasons, and you can just copy paste it to your own Visual Studio Code.
Yeah. Wait, but can we just host on GitHub or no?
We could do that too.
Yeah. Right.
Doesn't matter.
That's it.
Yeah. Either or. GitHub's probably the proper way to do it, but I'm a Replit fanboy. So yeah, we'll post it to GitHub. How's that? That's the proper way to do it. We'll post it to GitHub and you can download the code from there.
Exactly. So guys, how sick was this? How sick was that to create such an insane Python tutorial, such an insane Python program? Aaron, amazing job.
I think it's pretty dope. I'm just admiring the work that other people
admiring your work. Don't get too cocky, bro. Don't get too cocky on this. It's just
I said I'm admiring the work that other people have done, bro. That's the opposite of cocky.
Okay. I thought you said admiring my work.
Open your ears. I mean, what? I wrote 20 lines of code. It's pretty badass, but I mean,
Yeah.
I didn't do all the training. That's the hardest part.
Yeah. But that to me is insane. So yeah, but awesome job, guys. Guys, give Aaron a round of applause in the comments. Right, he worked on this for
all of us. Give all yourselves a round of applause.
I was partially involved in the code. I was just okay.
This good. Look at this.
Wow.
Holy. It's getting these pedestrians super accurately.
It's like stop. There's pedestrians in front.
Yeah.
Yeah.
And then the bigger the rectangle, the closer it is. You can do stuff like that. Like if there's a big rectangle, you can tell that the thing is close to you.
Yeah. Look at that. That's insane. That's cool. That is so cool.
Okay, this one's not working at all. This one's terrible.
it's like I think there's just too many people, man. Probably.
Yeah.
There's too much information.
I get a little bit confused with crowds and stuff.
Yeah.
If you had just people walking, on a white sand beach, just a single person walking, it would track it almost perfectly. But just because there's so much noise and stuff, it's not quite perfect.
Yeah.
But dude, this motorcycle driver is freaking.
He's trying to run people over,
Yeah, he's murderous, dude.
People are like, "The hell are you going?"
His name is Royal Jordanian, so maybe he's in Jordan or something. Yeah, I
Okay,
mean,
okay.
I found him this morning because I needed this video, but he has like 2 million subs. It's ridiculous
Oh wow.
for riding his motorcycle.
He just rides his motorcycle and he records it. Is that it?
I guess so. I
Wow.
mean, he probably talks about his motorcycle and stuff too. I didn't really look at his channel, but
Evil is like evil. I don't know how to say that. Evil is like, Aaron, do a project with me.
whoa, look at this truck. Got that truck hard.
Did you hear me, Aaron?
Yo, it's getting the cars in the advertisement. That's funny.
Where? Oh, the
Here.
up top.
Yeah, are those even cars? Oh, they're not even cars.
I don't know if they're cars. Yeah, I mean, guys, obviously it's not perfect, right? This is not perfect,
Yeah,
but still, it's insane.
it's more right than it is wrong.
Yeah,
just say that.
yeah.
That's a monumental task.
Yeah. Hey guys,
Monumental.
let me ask you a question. Like, what else? Let me ask you a question. What else would you like us to see? Like, what else would you like us to do in terms of, AI or face detection? Anything that you want us to do, like, let us know. Drop it in the comments below, right? Because we read your comments, right? So we have great ideas for what to come next. For we have great ideas of what you guys want from us, right? We read those comments. I am not kidding. So if you got any suggestions, right? If you got any suggestions on what to do, yeah, just drop it in the comments below. We'll take a look at it. Aaron, and then Aaron is just gonna take a crack at it, and then create something amazing, right, Aaron? Am I right?
Semi-amazing, bro. I mean, just whip it up.
Yeah, semi-amazing.
Whip it up overnight.
Like 1/4 amazing. 1/4 amazing.
Yep. And boom, cool projects. Any cool ideas you guys have for projects going forward related to Python and any kind of artificial intelligence, then drop it in the comments too. Then we can consider it, and maybe we'll make something. Yeah. Maybe we'll use OpenCV again. Maybe we'll use something else. Something else.
Somebody said. So we have Ido said to detect numbers. Okay, we could do that actually. Yeah. Detecting numbers like 1, 2, 3, 4, 5.
You could detect numbers on a page. Like if you had a piece of paper and you had OpenCV, you could technically scan that and then find out like all of the places where there's words. Like that's actually how PDFs are able to like scan the numbers and letters in it and like auto populate all the numbers and letters is through scan. It doesn't use, I don't think it uses Haar cascades. It uses something different, but same principle. You can detect different letters and shapes on a piece of paper. Same exact principle.
Gotcha. What about somebody said Sparsh asked age detection. I'm not sure if we can do that. That's a little bit hard.
Age detection?
Yeah.
I mean, in theory, it's possible. Like if you had like facial recognition, you know how Facebook can recognize your face and be like, oh, this is Kazi, this is Nas, this is Aaron. Tag your friend automatically. If it can recognize an actual independent face, it can easily recognize old versus young. So, yeah, you could, but it would take more training. You would need a lot of picture of old people and a lot of pictures of a lot of young people and to distinguish between those.
Yeah, that's true. But I think it's like when you get to like when you're 20s or 30s, it's really hard to get the exact age. Like if it can get the exact age,
it could be like old, middle-aged, child, infant. You could just split it into 4 groups. Infant, kid, middle-aged adult, and elderly, senior citizen. You could have like those 4. That's close enough.
That's true. So guys, if you want us to do like an age detection system, that would be actually interesting. And then we could age detect Aaron, and they'll probably say like 50, or something like that.
Yeah, the thing with that is I don't know if that exists on the internet. We might have to train our own Haar cascades, and there's other algorithms. Haar cascade is not the only algorithm used for this. But maybe
we had we had someone say Itzak said face expression detection.
Oh, like
smile, sad, like mad, be like, no, I'm mad. I'm like, you smile,
Yeah, we could do a smile detection. That'd be interesting. And just have it's like smiling or not smiling, because let's just keep it simple. Smiling versus not smiling faces.
Could
and
do
then
that.
You could have like a little label. It could say like smile on top. Yeah, that's not a bad idea. We can look into it.
So guys,
anything else?
Would you want us to create a face expression system?
A smile detector.
A smile detector system.
Yeah.
Because that way, if you guys don't smile, we could, I don't know, we detect some points, You like points from you. I don't know how, but we would deduct points if you guys don't smile. So yeah, sweet. I think that's pretty much it, bro. Right? We're good.
Yeah, that's it. So again, if you guys are interested in coding more and actually making a living from it, if you're not currently doing that, if you're Uber driver or working at a retail or fast food place or something like that,
yep.
We offer courses here at Clever Programmer to help you learn how to do that. So we teach you a bunch of different projects in Python and how to actually monetize those skills. So there's a 15-week program hosted by Kazi and our other Python expert, Jacob.
Yep.
And then also there's a little bit of me in there. We're going to add in some stuff in there at some point of me. And we all teach Python and how to actually use Python to make a living from it. So if you're interested in that, then definitely give it a click in the description. There's a free 3-part masterclass, and also the actual course is there, so you can check out both. If not, then yeah, just keep watching us on YouTube, and thanks for watching, you guys.
Yeah, sweet, guys. And I just want to say, guys, just one small thing, guys. If you're interested, like I said, with the Profit with Python, you get amazing success coaches. You get to learn how to make a killing with Python, right? So it's not just about teaching you skills, right? But it's also teaching you about how to actually make money from that, because that's the most important thing that you're gonna get it from a course, right? We get weekly training calls. Literally, every single week, you get a coaching call from a developer who knows his stuff, right? You have an amazing community who helps each other, and you have an amazing Facebook community at the same time. So, yeah, if you're interested in, becoming a Python developer or learning Python and just making a killing with Python, where do they go, Aaron?
They can go to the link in the description and check it out there. Profit with Python.
Profit with Python, guys.
With Python course.
Yep.
And then there's also a free 3-part masterclass. It gives you a little bit more information about making money as a Python developer. You can check that out. It's just about like the opportunity there is and stuff, and there's some activities in there. You can check it out.
Sweet.
And then you can join the course after if you want, or something like that. But yep, that option's there for those who are interested. For those who are not, come back to the small detector next time.
Yeah, the small detector. All right, guys. Awesome, guys. This was amazing. This was so much fun, guys. Oh, hold on. Somebody evil said Evil says my heart is Python.
My heart is Python.
My heart is Python. Yes. What about JavaScript, bro? What about JavaScript? JavaScript cool too. You guys are not, not cool. Anyways. But sweet. Awesome, guys. In that case, I think we're done here. Hope you guys have a great day. If you guys have, I don't know. Hope you guys have a great day. And other than that, we will see you in the next video. Right, Aaron?
Yep. Next video, probably tomorrow, right?
Yeah, probably tomorrow.
Scheduled for tomorrow.
Yeah, I think so. Awesome, guys.
Stay tuned for that, you guys.
Stay tuned and have a great day, guys. Let's go.